Imagine a world where time travel is no longer confined to the realms of science fiction.
Time travel.
It's possible, sir.
Where do you come from?
I'm from the past.
Imagine being able to plant crops in the morning and then harvest those crops that very night. Or how about healing a wound with a localized time acceleration device? A device that can speed up time in a small focused area, reducing the time it takes to heal wounds. Take a moment with me to imagine this world. A world where time is no longer a constraint, but a tool. Remember Back to the Future? The flux capacitor is a fictional device from the Back to the Future movie franchise that was used to achieve time travel. According to the movies, the flux capacitor is powered by plutonium and generates the 1.21 gigawatts of electricity needed to create a temporal displacement field. Sounds like a giant load of fiction, right? The truth is actually a lot stranger than fiction. Let's explore further.
And you told me the whole story. You were standing on your toilet and you were hanging a clock and you fell and you hit your head on the sink. And that's when you came up with the idea for the flux capacitor, which is what makes time travel possible.
Right, Scott!
going on, everybody? I'm the Benefactor, an independent researcher looking into different fringe areas of science, obscure areas such as the rodent coil and anti-gravitics. Today, we are going to be doing some debunking of the Mythbusters work on the Bedini motor. Now, give me 1 second to pull this up. Now, when I found out that the Bedini motor had actually been covered by the Mythbusters, because I'm a huge fan of their work, by the way. I used to watch their episodes like nonstop. So they have some brilliant engineers on their team. And when I found out that they actually tried to do the Bedini motor, I was fascinated, but immediately slightly skeptical. Because I know if they didn't debunk it in their video, it would be all over the news, right? And it wasn't. So I did some digging. I found the episode. We're going to play a couple of clips from it, and we're going to show you a break. I'm going to break down, and actually we're going to play a video of Bedini breaking down himself exactly that what they did wrong. And it was so negligent that it was almost like a hack job. Because, as you know, when you're trying to reverse engineer technology like this, you want to follow the inventor's instructions to a T, which they did not. Now, if you're taking this in any other context, that's a big safety hazard, right? Especially if you're working on movie sets and all that, which these guys often do. So, the fact that they blatantly disregarded so many of the inventor's not only suggestions but requirements for the system tells me that this was not only negligent, but it was a great disservice to humanity because a lot of people watch this show. So let me pull up the clip. All right, be prepared, people. This is pretty disturbing. How grossly negligent they're not following the instructions of the Bedini motor. Give me 1 second. There it is. There we go. All right.
What is next?
The Bedini motor.
The Bedini motor. You know, the Bedini motor is like the holy grail of the free energy freaks.
It couldn't be simpler.
Hey,
A battery.
hold on. See that condescension right there? That condescension is very telling. Like, they're going into this almost assuming that it's BS, right? Which, it's okay to have a healthy dose of skepticism, but you have to also be open-minded about this stuff too. No, they don't have a show. And you know what? I'm glad, because this is, like I said, this is a total disservice to humanity. If they tried to debunk the Bedini motor, which it effing works. I don't care, it works. And the fact that you can get more output than input, which I didn't believe before I actually achieved it, so.
Drives a motor which spins up a flywheel, which charges wire coils, which in turn recharge the battery.
All right, so right off the bat, see here? Right off the bat, Bedini does not charge a battery with itself. Come on, Mike, step in here. Give us some context right here. Bedini's motor is supposed to charge a battery with another battery. It's not supposed to charge the battery with itself. So right off the bat, they're getting the configuration wrong, unless I'm wrong. But all the Bedini circuits that we've gone over on this show have all involved 2 batteries, not 1.
And bingo, a perpetual motion or over unity machine.
It's important to keep an open mind and realize
it's important to distinguish between over-unity and perpetual motion.
Realize that all the principles that drive the over-unity machines operate outside of everything you've ever heard about science.
For instance, if your over-unity is 155% like my system, that is not perpetual motion. You need to have at least 200% efficiency to recharge a battery or to perpetuate something indefinitely, right? And even then, you're constricted by the wear and tear of the materials you're using. Right, Mike confirms it. He's the resident expert here. Mike Does is the resident expert on the Bedini motors and the Bedini circuits. He's been researching Bedini for a long time. And he says, right, 2 batteries, 1 bifilar. Okay.
What did they
Give him
do?
the latest
Well,
smackdown,
for starters,
Bedini.
there were no magnets on the flywheel.
What?
They just ran this out of the blue, but it was only after there were 400 or 500 people on this SG group, that we're starting to build these monopole motors and starting to get results with the motor working, and they seen that I was charging the battery and doing the mechanical work. Just in about the middle of this, all of a sudden out comes this myth. It has nothing to do with a schoolgirl motor. It's something that was done in 1984. It's something that Watson proved without a shadow of a doubt that it operated, because he isn't here anymore. Where that went, nobody knows. But it had nothing to do with the schoolgirl motor. But yet here they come, right at the peak of this schoolgirl motor. Here, we're going to get this guy. We're going to come out with this program and
That's exactly the mindset they went into it with, right? That's exactly the mindset they went into it with. They went into it thinking they were going to debunk it, knowing that they knew what the outcome was before they actually did the test. You want to know why? Because this is how mainstream academia works. Whether they were doing it nefariously or not, they don't believe that you can get more output than input. That closed-mindedness is very disingenuous and does a great disservice to the viewers who are watching.
disprove that this thing, it just doesn't work. Well, yeah, you could see that it didn't work. The coils weren't wound right. The motor wasn't right. There were no magnets on it. The mass wasn't even, there was nothing on this thing that remotely resembled what Watson did or what I did. It was just a mismatch. It was a Rube Goldberg machine is what it was. Never did they come.
So they basically, and we'll see this in a second, I took a look at, I watched maybe the first 2 or 3 minutes of this. I didn't watch the whole thing yet. But you'll see in a minute, they basically made a caricature of his device going into it, trying to disprove it, knowing that they would because they didn't follow his instructions. They had to have known that. You can't say that, oh, I just accidentally forgot to put magnets on the motor. It is a magnet motor.
Contact anybody. And they did it on national TV just to discredit the whole thing.
Wow.
That's my opinion of it.
So even
You
he
know,
thinks it's a
there
hack
never
job.
was any kind of comment. And you couldn't send him an email, you couldn't do it.
Yeah, see, this is very telling right here. Okay, so say I'm working on a free energy device or a device that supposedly obtains something phenomenal, right? Something that science says is impossible. Immediately, if I can't get it to work, after following the instructions to a T, if I can't get it to work, I'm immediately contacting the team of the inventor to see if he can help me out and try to get it to work and see if I did anything wrong. Right? Yeah, no, I'm starting to see that, Crypto. I'm starting to see that, dude. They're a big joke. And I think Bedini in a second, he'll even say that they never even contacted him. Right? If they couldn't get it to work, Bedini was still alive at this point. He passed away around 2016, I believe. But They could have easily gotten on the email or gotten on the phone and trying to contact him like this university did with Malcolm Bendel when they couldn't get the thunderstorm generator working. They contacted him and said, Malcolm, oh, we can't get it working. Do we do something wrong? Or will you take a look at it for us? He got it working, right? They didn't have any intention of getting it working. They didn't want it to work. Mike seems to think you immediately start over from scratch. You don't contact the inventor. But I think you would need to contact the inventor just to make sure you didn't do something wrong and intentionally. Or unintentionally, right? How would you know?
Anything. Why don't you do this correct? There was none of that. It was just, we're going to just disprove this and see it doesn't work, folks. Here it is. Of course it didn't work. Didn't even have any magnets on it. And the most unique thing about the Mythbusters is they had some MIT professor standing there that knew better.
Wow. Yeah, they just assume their audience is stupid. And that's what I take from this that is the most disturbing, is that they assumed their audience was stupid enough to believe that they actually tried to, in earnest, recreate the Bedini motor and try to follow the inventor's instructions, which they did not do.
You know, that knew that this thing wasn't going to generate anything because he left out the magnets. You know, there was nothing to go by the coils, nothing, no energy to be generated, just a waste of energy.
MIT's Dr. Geo Holmesy has been helping the guys by assembling the contraption. And with his pedigree, they're quickly in business.
Free energy, man.
Here we go. Activate the modulator.
Modulator activated.
A modulator switches the motor on and off, so preserving power while the flywheel keeps on spinning, in theory, replenishing the battery.
Okay, it's spinning up. I can hear it getting slower.
Yeah, it seems to be.
I don't think I need a meter for this one.
In a sudden burst of free energy, the Bedini machine runs down.
Sounds like my grandfather.
That is not.
Oh, getting sick.
That is not a Bedini machine. That is a pathetic piece of wood and metal. It does. It makes me mad, right? It makes you infuriated knowing that these professionals who have the responsibility and a platform to disseminate important information are just doing a complete hack job on this guy. Sounds like a three-phase motor. Yeah, I mean, right off the bat, you're trying to recharge the battery with itself. That's not what Bedini does. That's not what he says to do.
It's draining more from the battery on each cycle than it's putting back in when it recharges.
Shame on you
One
guys,
big
man.
problem with perpetual motion machines. They're
Start
not
throwing
perpetual.
rotten fruit at the screen
That's
in a
an
second.
efficiency of over 100%.
Kind of makes you feel all warm and fuzzy inside, don't it?
Well, Crypto, what you have to understand, bro, is I used to look up to these guys. I used to love this show. And now my whole world is turned upside down, knowing that they're effing frauds, basically. Yeah, everybody on TV is an actor. You know, it's the sad reality we live in, and we put these actors on pedestals.
If you mean it makes me feel like I feel about the Easter Bunny or Santa Claus, yeah, that kind of warm and fuzzy, because it's a fantasy.
More condescension. I have a system that outputs more energy than it's taking in empirically. Go F yourself. All right. With that, we're going to go back to some Bedini and see what he actually says about the Bedini motor. Yeah, it's very irresponsible. So I'm going to go over to Old Man Builds. He's got a lot of great stuff here. If you haven't subscribed to Old Man Builds, I suggest you do it. I'm going to put his link in the chat for everybody. Oh, there we go. So this is Nathan's channel. He's got tons and tons of these videos in full, like hour, 2 hour long videos, some of them. I know one of them is actually a full 4 hour long lecture by Marco Rodin, which is astounding. I love everything Marco does, so I just eat it up. So go to Nathan's channel. If you haven't subscribed, I highly suggest it. And if you haven't subscribed to my channel, hit that subscribe button and hit the like button. We're going to watch some more Bedini and see what he actually says about the Bedini motor and how to properly configure it, and kind of compare and contrast what these clowns did on Mythbusters. Nice. Someone already subbed. I like that. That's a cool name. Someone. All right, let's check it out. Let's do a search for Bedini motor in here. The glass case motor. I'm not exactly sure. Mike, do you know exactly which motor they were trying to replicate? Just the Bedini motor, or was it the SG? I think it was the SG. Didn't look. And also, you can catch Nathan and I. We're hosting Sean Calderon on Monday. He's got some amazing work with his Tesla coils. I was very blown away with his work with the Tesla coil. I might show you guys in a little bit after Bedini. Give you a little sneak peek of Monday's podcast where he's going to be demonstrating some of the stuff, I believe. But we're going to have Sean on, and he's going to talk about his Death Star Tesla coil. I do not. No. I don't believe in trying to monetize on the device itself, or the science behind it, rather. I try to do that all open source and for free. What I might do in the future to help subsidize funding for this business, this channel, is start selling the Rodin coil frames sometime in the future. That's definitely a possibility, but in terms of altogether over Unity, no. I have a do-it-yourself guide for the Rodin coil over Unity system, the 0-point energy generator Mark 1. It's free. Everybody can download it, and I am going to be, when I get my spare frame, I'm going to be hosting a workshop for everybody to follow along. It's going to be a class. It's going to be an all-day thing, and you can actually go and hit the notify button right now. I don't know exactly when it's going to be, so don't pay any attention to the date. But it'll be an all-day thing, and I'll teach you how to wind it, how to configure it. We'll do the process of taking care of the ends, the leads. Grind them up, burn them, insulate them, whatever, and separate them by color. That's what I like to do, because if you have more than 2 outputs or leads, it kind of gets confusing when you want to do multiple different kinds of connections. So, Internet Skippy, give me 1 second, and I'm going to close a window or two. All right. Hopefully that helped. Anyways, we're going to be hosting a workshop for the Rodin coil. So I will be teaching everybody, or as many people as I can, how to build these systems. But in terms of selling them, like built and whole, no. I don't have any plans on doing that, and I don't recommend it. Basically, what it boils down to, and this is some serious SHIT right here, is you don't F with the money, right? You don't try to screw with the market or intrude on the market of the energy systems that are in place, the energy industry. So that's one thing that I think a lot of inventors make. One mistake I think a lot of inventors make is they try to overstep their bounds. And, you know, you got one little inventor against basically the top of the world, you know, the richest of the rich who own everything and control everything. So, you know, you're not going to win. Someone says stream ended. 1 second. It says it's still live on my end. You guys sure? Because I still see it. It says it's still live on my end. Yeah. You guys sure? Because I still see it. It's probably just Skippy. My internet gets a little jumpy sometimes. Whew. No, I always hate it when this thing crashes. Sometimes it crashes and you know, I gotta restart the stream and everybody that was interested is no longer interested. You know how people's attention spans are low. I know I have a very short attention span. I got ADHD like a mofo. You can't capture my attention for too long unless it's something that I'm really passionate about, like these topics that we talk about on the podcasts and these live streams. YouTube. Yeah, no, the internet's just a little jumpy, Elijah Tack. So, you know, and it sucks because this happens sometimes, but it's my internet. I just need to upgrade my internet. That's all.
That's we're going.
So, I think Bedini uses open core because he wants the etheric to flow. If you use a toroid, it's closed loop. The outside cannot get in so easy. Oh, interesting. So, as I've said before, Mike is our resonant circuit. Resident circuit. He's our resident expert on Bedini. So I'm going to Mike. I'm going to play Bedini's SG schoolgirl machine. I think this is what they were trying to replicate, but they said Bedini Motor. I mean, I know this is a motor, but it looks nothing like what they were doing. So help me out in the terminology. Is this, or could this be what they were trying to, at least in name, be replicating?
I'm going to explain.
Because I didn't see no flywheel. And obviously you got two batteries here. They only had one battery. Like, I don't know, man. These are basic things, dude. It's like basic stuff. But I think this is the one they were trying to replicate. So let's watch this and see how Bedini explains it.
The history of the SG machine.
Okay.
And
so, and the brief history from me and what I understand of the SG machine is SG stands for schoolgirl, and the schoolgirl circuit arose when I guess one of John Bedini's friends had a daughter who needed to do a science project, and Bedini helped her with a science project, and he said the circuit is so easy, even a schoolgirl can do it. You know, even a schoolgirl can put it together and figure out how it works and understand it. Now, to be fair, I have struggled just a little bit understanding the Bedini circuit, but that's just because my idiosyncrasies and learning issues. But it really is a simple circuit. Like, it's not very complex.
And the three modes of operation that's never been explained on the machine. So if you want to come around here.
The transistor, and that's something I need to be more familiar with. I need to familiarize myself with the function.
This was the kit that
abilities of the transistor
that we built, and we only made 10 of these kits. So And this SG is built just a little bit different. You notice it has 2 fans. That's to slow it down more with wind drag and to sort of change what the triggering's doing. There's also 9 wine.
So Elijah Tack has schematics. You can email me. Here, I'll put my email in the chat. Just email me and I'll put them up. So that should work, and I'll check my email in a minute. So Mike says the 1N4007 is the diode Bedini uses. And, oh, the 2N3055 is the transistor. Okay, so I got it backwards. So it's the diode that you really need to understand, not the transistor. Interesting. Yeah, transistors are a little bit complex. I haven't really studied them. But diodes are easy. They just basically force energy in one direction, and they don't allow it to return in the other direction. So, interesting. Yeah, I know. What was it you were saying, Mike? The diode forces the energy back in the way it doesn't normally travel back. Like normally energy travels from negative to positive, but it was going from positive to negative, or being forced in the reverse direction, if I'm not mistaken.
On the coil. And it's wound in the counterclockwise direction. In other words, so the motor is in a traction here, or the energizer, which way you want to term it. Most people say motor, I say energizer. But, and they're all north poles, facing out. And there's 21 magnets around the wheel, so there's an odd number of magnets around this wheel. All right, so what I want to do is on this side is the primary battery, and this is the voltage on the primary battery. Now normally batteries will stand around 12.65, and this is going to be the secondary battery, and what's on the computer screen is we're going to take 1 amp.
Yes, but the placement of the diode explains everything about the circuit to the end user. The radiant energy is reversed polarity to your battery energy, DC, that entered the run winding. Sorry, my little icon is in the way of... Yep, entered the run winding. So this is Mike Does. He's our resident expert on the Bedini devices. If you have any questions, by the way, drop them in chat for Mike. He's very knowledgeable on this stuff, and I'm actually going to be doing a live stream with him at some point in the near future when I gather the materials for phase 2 testing of a Rodin coil system. When the 0-point energy generator that I built moves into Mark II territory, phase 2 testing will include the Bedini schoolgirl circuit, and I want to try to do the flywheel as well. Like, that's something that I really want to do. I don't know if I'll be able to do the flywheel, but apparently there's a version without it that we can try. That's going to be very interesting. And when that happens, I'm going to have a live stream with Mike, and he's going to, work with me on, developing this phase 2 circuit for our Rodin coil system. And I'm hoping that it'll increase from 155% efficiency to maybe more, hopefully.
1 amp hour out of this battery. And then we're going to put it back by showing the 3 modes of operation on the machine. So, a little bit of history. The actual year was 1955. And I always had a fascination of taking a DC motor and running that motor and hooking it to some form of generator. Because I always thought, well, you know, if I hook it to a generator, and I'll just abbreviate it, GEN, that I could put this back to the primary battery. In other words, the battery out here. I always thought that, well, you can run the motor, and remember, a kid's thinking this.
How old were you?
It's not very old, maybe about 9 or 10 years old, and so I always thought, well, you can take this motor and hook it up to the battery, and the motor starts running, right? And of course, not having any basic engineering, but just being a typical kid, in a kid's mind, right? He thinks, well, that's possible.
It's simple, right?
Yeah, it's very simple to do. And run it back to the battery. However, everybody knows exactly what happened here. The generator tried to put the energy back to the battery, but then the motor drew more current, and so it slowed down and slowed down and slowed down until there was no more generator. Years went by. I mean, I thought about this for a very long time. And I said, there must be some way to do this. So, but in the meantime, what I was doing was I was experimenting with this motor. And I found out that if you put a capacitor here, and at that time, I think the biggest capacitor that I could get was like 3,000 or 4,000 microfarads. That this would charge up to like double the battery voltage. All right, so if this is, at that time, I think this is a 6-volt battery, so it would charge at 12 volts. So I found that if I broke the positive line, right, and put a push switch here, push button switch, that I would wait for the capacitor to charge up. And meanwhile, there's no load on the generator, so it's not drawing very much current, all right, in amperes, because at that time motors weren't very efficient, maybe 40%, 30%. And maybe this was 1.2 amps. And I found out that that you would let this run, and you would watch this with a meter, a voltmeter. And when it got to 14 or 15 volts, or whatever voltage the generator put out, that the cap could charge.
Mike says this clip is nuts. Play after this. So yeah, we won't play this whole 2-hour long clip. I think we'll play a good chunk of it to get an understanding and kind of compare and contrast what the Mythbusters hack job looked like compared to Bedini's magnificent work here. And then we'll jump into that clip and others if anybody has anything they would like us to discuss tonight. Again, you know, I don't know if we're having Free Energy Fridays. I hope we do, but in the event that we don't, this shall suffice, and we will make do.
Which was basically double the battery, so 12 volts. You'd push the switch real quick, and you'd see the deflection on this amp meter and the deflection on this amp meter in amperes. And what would happen is you'd hear the motor speed up for just a second. And then you would let it charge back up, and then you hit the switch again. All right? So for years and years and years, and by that time I was in the military, and I was still thinking about this the whole time. How could you make this all work to where you have a motor or because the generator is going to become an energizer when it's free from it's drag.
What do you mean by energizer?
Energizer. In other words, it's just a potential. There's no current involved. So there's just a high voltage here. Okay? And it's being captured by this capacitor, which is charging, and then the discharge is current. So, because you're storing the energy, you have really no current here. You're not trying to drag this generator back down. You're just charging this capacitor, and then you're pushing this little switch. And then you're discharging whatever's in this capacitor back across the primary of the storage battery. Well, that worked to a certain point, but how long were you going to sit there and push the switch? So, what I did was I came up with all kinds of schemes in my mind. That's what, you know, young people do. They always come up with a scheme. So I decided what I was going to do was I was going to take this DC motor. And I thought about this while I was in the military. Of course, I was going to school in the military to do, you know, top secret communications work. And I was stationed to a base in Germany, in Gerplingen, Germany. And that base had some interesting little things that I really can't talk about. But some of the things that we do was a cleanup. And this was underground. And so...
A cleanup of what?
Yeah, cleanup of whatever was left over from World War II.
Nazi Germany stuff?
Yeah, Nazi Germany stuff. And so there were batteries, and there were, you know, motors, and there were generators, and I sort of got inspired, but I didn't have any time to actually work it out.
Yeah.
I couldn't work it out.
Was the German stuff pretty good?
Oh, yeah.
Yeah.
Yeah, the batteries were kind of interesting. They were mercury batteries, and you could turn a little handle on them, and it's like they came back to life. So that's as far as I can go with that. But so what I thought about was during this whole time was taking this motor, and I really couldn't wait to get back and do this. And again, we had the DC generator.
Now, come on, Bedini. You cannot drop a bombshell like that on us and just continue on like it's nothing. The Nazis had mercury-powered batteries? This is incredible. So, if some of you are aware, some of you might not be aware, that the Nazis were working on reverse engineering ancient technology. They had something called Die Glocke, or the bell. And the bell was supposed to be an anti-gravitic device. And you know what? They were obsessed with the esoteric and the occult and the ancient Vedic texts describe Vimanas, which are powered by, wait for it, vortexes of mercury. Dun, dun, dun. All right, but I digress. Back to Bedini.
And the DC motor. And the shaft that was coupling these two. And of course, this is spinning this way. And so what I thought about was a scheme. I thought about this scheme about, okay, let's do this. Let's take the DC motor.
I think we just got an incoming email from Elijah. I'll check it out,
Take a
Elijah.
commutator from another motor and put the brushes on the motor, on the commutator. And of course I was going to have to start this by hand because this always didn't end up across the two contacts. And so this is what I did. is I took the battery, which by that time was 12 volts. So this is now 12 volts. And the way I hooked it up was this way. So we're just going to call this plus, this minus. Okay, and now I had a contactor. So now I've got a primary battery, right? And I had to give the motor a spin, so I would sit there and you would take your hand and the shaft, right? And of course it would make contact, right? And then the motor would be pulsing while it was running. And then I thought to myself, well, I don't want to run back to this battery unless this is off, because if this comes back to this battery and this is on, then I've defeated my purpose, because all the energy is not going to go to the battery. It's going to go back into the motor. So there, a young man learns that there is no perpetual motion there. All right, so then I thought to myself, what if I just take the generator and make another...
Now, keep in mind, he's not talking about perpetual motion in the traditional sense, I don't believe. He's talking about perpetual motion in the electrostatic sense. At least that's my interpretation of this.
Contactor and make the other contactor so the brushes are this direction while these are this direction, and leave these brushes the same, like that.
So do these spin?
Yes.
Okay.
They're on the shaft.
Okay.
All right. Everybody knows what a motor commutator, well, maybe they don't, but a motor commutator has segments in it like this that the brushes make contact with.
Okay.
So actually there's a hole there, and this commutator is on the back of the shaft in the motor, inside this motor.
So it's spinning around and contacting the brushes. Okay.
Yeah, it's making its contact inside here, but now this is saying we don't care if this has contacts all the time. We're only giving it power part of the time. Mm-hmm. All right, just however many segments are making contact at that time. All right. So, what is this saying? That current's only flowing when this is contacting. So we're only using energy from this battery during this connection period. Now that's time. It's how many of these brush segments did I wire together at that time. And see, the segments would look like this, and then they're all wired together. And that's actually making the switch because it's shorted together. So there's a wire that's going from this one to this one. Actually, I should put that in red so you can see this. But now I want you to understand, I want everybody to understand out there that this has taken 20 years.
Yeah.
You know, you're going through your thinking all the time. You got this fascination in your mind that you think you can do this. In reality, every book is going to tell you you can't do this. So, once again, the wire's in here. So that's in the red. And once again, the wire's in here. And that's in the red.
So John, I don't understand. If those things spin...
Well, they're spinning on this shaft.
Yeah. Then why does it matter if the ones in this ones that you haven't got connected, that they're at 90 degrees to the other ones?
These are there, but they're not connected. In other words, they're not connected to these. These segments are connected together, and the other ones are separated. In other words, the motor commutator looks like this, and the coils of the motor go between these commutators, like this. You see? All the way around.
Okay.
And they form the loops of the motor. All right? So when you energize the motor, these become magnetic fields against the permanent magnets.
Okay, but
So it's this, Pat. Look. It looks just like this. It's a rotating loop. And the brushes make contact with this loop, and the magnets are out here, north and south. And so when they make contact, that spins away. It's in every textbook.
But I still don't understand those two spinning bits. Why?
Well, I connected the motor to the generator.
Okay.
But as I said in the beginning, that when I did that, okay, without this arrangement, right, that this was drawing continuous current, and if I brought this back to the battery, this was drawing much more current until the thing just slowed itself down and didn't generate anything.
Yeah, but my question is, are these spinning independently or?
No, they're
fixed?
connected together. They're fixed on the shaft.
Okay, so that's, I was thinking of
Right.
each going.
So if we're looking at it, right, let's just say we can look through the two that I had,
Okay.
right? What you would see is this.
Okay.
And I would call these two A and these two B.
All right.
So now there's a phase difference, isn't
Yeah.
there?
Okay. Now I understand.
Okay.
So right now I'm just going to give you a visual compare and contrast between the two devices, the device that the Mythbusters put up and the actual Bedini device.
As it approaches 14.97, it's already at 15 volts. So it's already boiling the battery. In the chemical. So it's going to flatten out. Okay, so we'll stop this. We don't need to take any more from it. And now look at what the forced charge from it. So we'll stop this. We don't need to take any more from it.
Look at the difference between these two devices. Are you trying to tell me that they claim to debunk the Bedini motor without a flywheel or fin or magnets on the motor or a secondary battery? What the F? No, not busted. You're busted.
From it.
We busted
and
you.
And now look at what the forced charge, where it's going to come in and settle.
I think we've successfully busted the Mythbusters on this one, guys. Alright, so I think this is a good segue into a couple of diagrams that Elijah Tack was gracious enough to send me. And we're just going to take a look at them real quick, and then we're going to jump into another video that Mike wants us to take a look at regarding Bedini. Alright, I hope you guys can see that. It's a little blurry a little bit. I try to make it as clear as possible. As you can see, it's handwritten. But Elijah Tech sent me this. A couple of diagrams for some Bedini circuits, I believe. And real quick in chat, if you want to just drop what's going on in this diagram for us, and I'll take a look at these notes here. What would the coil be for? Longitudinal waves as pancake style? You know, I'm not sure. That's a good question for Mike. He says, my NDA is related to specifically specialty alloy. So I can share 0-point energy content freely. Awesome. Yeah, as much as you can talk about, for sure. I'd like to have you on Discord, but if you can't get on Discord, just try to chat with us in chat here, and I'll do my best relaying it to everybody who's not actually in chat. I know we're streaming on Facebook right now. We're also streaming on Rumble and Twitch. So if you guys are watching on those platforms, YouTube is my main headquarters for the channel. Those are my backup channels primarily. But if you would like to support me, I do offer Divine Science episodes a few days early. I try to get them out at least 2 to 3 days early for my members who have paid for membership on Facebook. And that I lowered to 99 cents, and I don't think I'm going to increase it. I think that's a fair price. Ooh. See, here's where I'd like to ask some questions. It says Byfield-Brown effect. Asymmetric capacitor with electrodes of different size move in direction of smaller electrode. Byfield-Brown effect. You know what? Let's ask Leonardbot about the Brown effect. Let's see what Leonardbot has to say about that. That's interesting. Again, if you have any questions yourself, Leonardbot is free. lenr-bot.com for all your inquiries in 0-point energy, anti-gravitics, sacred geometry, and more. LENR stands for low energy nuclear reactions. Did I spell it right? Let's see. No. Missed the E. Oh, so we got an O-Day clip. Understanding true charge separation. And I believe that's what's going on in this diagram. If I'm not mistaken, it looks like, at least that's what it looks like, a separation of charges is going on here. Phone scanner, please correct me if I'm wrong anywhere. No, you're good. I don't have the credentials to check you on your work here. I'm new to all this. I built a rodent coil system, but you know, that's about the extent of my knowledge is the rodent coil. All of this is new to me. But yeah, I don't have the academic background to check your work, dude. I'm just trying to understand it, man.
same in the case of Hutchison effect. It's the same in the case of Yul Brown. It's the same in the case of Evie Gray. In the case of you name it, Henry Murray. It does not matter. They are all the same thing. They are all the same thing. And if you understood,
give free
that
energy
is
equation.
The big secret.
Oh,
it's
hold
true.
on. Elijah Tack said, this is free energy equation with electric field and light subbed in. This is to represent the monopole in Malcolm Bendel's work. Wow. That's awesome that this plays into Malcolm's work. I didn't even know. You have to explain it to me a little bit, and now I'm starting to see a little bit of the connection here. Let's go back to Leonardbot. Let's summarize with Leonardbot and see what he has to say about the Byfield-Brown effect. So Lenny says, the Byfield-Brown effect is also known as the Byfield-Brown electrokinetic effect. Refers to the phenomenon of producing thrust or propulsion by applying a high voltage to a pair of electrodes in a close proximity. The effect is named after Thomas Townsend Brown and Paul Alfred Byfield, who first observed and documented it in the early 20th century. It has been the subject of various experiments and claims, suggesting that it may have potential applications in propulsion systems. That's awesome. Yes, and Malcolm Bendel's work does go into propulsion. I mean, he in terms of field propulsion, because remember, the ultimate application for plasmoids is space. They actually work better in the vacuum. This is very, very advanced stuff. I wouldn't even know where to begin to break this stuff down. Space as aether, creative thinking. It is interesting to derive what drives a thunderstorm generator from thinking of light and electrostatic potential as a liquid crystal solidifying into something. No, it's not gas. I'm sorry. I have bad handwriting too. This is actually really good compared to mine. But I'm struggling a little bit here. So if you could help me out with that word, solidifying into what? The phase transition represents the creation of solidification of reality that one is aware of. By using rotary electrostatic potential and F power can be applied to mankind. The truth will set us free. God bless the reader. I love it. I love it, love it, love it. Every bit of it. Awesome. This is awesome sauce, guys. I wish solidifying into grains. I thought that's what that was, but I wasn't sure. This is really cool stuff, but it's going to take me a while to break some of it down. Audio's low. Is that better? Testing 1 2. Testing 1 2. For some reason, I think the microphone stand may be pointing backwards. A little bit better. Yeah, it's registering in the low yellow, so it should be okay. Hopefully, now. Anyways, so here's a little summary of the key concept here. Let's read that, and then we'll close up with this. What's up, Ackaby? How you doing? At star example on previous page from Gibb free energy concept, we derive the energy of light equated to bond strength. We can substitute this into our probability E for interesting result. If R is greater than 0, in other words, real particles, and H is always positive, since we observe F is greater than 0, even though it can be negative, that leaves the charges need to be opposite sign to satisfy, e.g., example or equation, relative. At max of E, previous page, okay, so and it goes into a bunch of gibberish for me. I don't understand that math, but so he's basically saying, I have to reread this. Hold on. He's saying that from the Gibbs free energy concept, we derive the energy of light equated to bond strength. We can substitute this into our probability E for interesting results. I'm not sure I understand exactly what you mean by that. Derive the energy of light equated to bond strength. We can substitute this into our probability E for interest. I must not understand the math enough to understand the context here. You have to provide a little context for us. Okay, he says equation. Okay, so that's what e.g. equation. We get negative frequency factor at this 0 point, basically. Oh, wow. Okay, that makes a lot of sense. All right, so he's basically saying we get negative frequency at this 0 point. That makes a big difference. You know what? I'm going to ask Leonardbot about this and see if he can clarify a couple of things. All right. So we're going to ask Leonardbot, what is negative frequency and how is it related to monopoles and the 0 point? All right, Lenny. What is negative frequency, and how is it related to monopoles and the 0 point?
Negative frequency is a mathematical construct that allows for the analysis of real signals using a complex number framework. It involves the use of complex numbers and necessitates the existence of both positive and negative frequencies. This concept is relevant to the analysis of waveforms and photons, and it has implications for the understanding of light and electromagnetic radiation. Negative frequency is also linked to the theoretical possibility of negative energy and its relationship to monopoles, as well as its association with rotational currents in particles such as electrons and positrons. This concept is an important part of the theoretical framework used in physics to understand and describe wave phenomena.
Thanks, Lenny. Hence, superconductivity, once frequency goes to infinity, global movement is frozen, if you will. But frequency can still move charges forward over our frame of time since electrons tunnel. Interesting. Electrons tunnel. They tunnel like plasmoids? Or maybe plasmoids just microscopic, or electrons just microscopic plasmoids? Like quantum-sized plasmoids, maybe? I'm glad it checks out with my intention. Yeah. So LeonardBot is a great resource. If you ever have any questions about your own research projects, or you're just, an amateur and have questions on some of these things that we discuss, go to LeonardBot, lenr-bot.com, and he'll hook you up, man. He'll hook you up with timestamps. He'll hook you up with websites that are relevant to your inquiries, and also he'll summarize it with he can summarize your inquiry with AI and answer questions for you like any other chatbot. Let me drop that in chat for everybody who hasn't had the opportunity to check out LeonardBot yet, courtesy of anonymous affiliates of the Martin Fleischmann Memorial Project community. Let's thank them all right now for this amazing job they did with LeonardBot. Yeah, Elijah Tax said yes. 2H diameter plasmoid from my calcs. That was, I had somebody on the other night, and they sent me a link to one of their videos, and it was describing something called plasmatons or something. It was like a quantum scale bit of plasma, basically. And I'm like, oh my God, that's it. It's just a fractal. It's a smaller scale plasmoid. And is that what electrons are now, I'm thinking? Electrons are just microscopic plasmoids? All right, that was cool. That was really fun. Yeah, if you have anything, it's fractal. If you have anything else, feel free to send me. And if you want to jump on Discord and chat a little bit, let me know on any of our live streams, minus the ones that we do our podcasts on. But these free live streams, anybody, yes, I believe so, but beyond microscale. Yeah, like quantum scale, brown microscale, quantum. My bad, that's what I meant. Quantum scale bits of plasmoids. But yeah, if you ever want to get on Discord, and chat about this stuff and explain your research and your work, I'd love to have you on. And I think we're trying to do a show actually tomorrow to have Gerald on demonstrating his coil. Hopefully. Yeah, we're gonna. Yeah, of course. And we're going to now move on to more Bedini. Where was it? We had the video. Damn. I got to load the video again. So Mike does sent me a video, and he said it was, and I quote, nuts. He said, this clip is nuts. So I'm going to take his advice and play this clip. And hopefully it doesn't actually show
Chart makes
nuts.
We know Trump will sign a national abortion ban.
Shut up.
I can't figure out what's going on with this camera. Is it just me, or does it look like there's some kind of autofocus making everything look trippy? Like, look in the background. Look at this guy. He's very weirdly animated. I don't know. It could be the frame rate. The laser tapes. So it looks like there's no input power, if I'm not mistaken. Let's see what the description has to say. If this is a legitimate device, this is incredible. But it's not surprising because, again, if you're living in a dire situation, no description. If you're living in a dire economic situation, or you're impoverished, or you're in a third world country, you're gonna try, or at least I'm gonna try, anything possible to generate energy. And if free energy is something that is, overlooked in first world countries, then third world countries are definitely not going to overlook them, because they're not going to subject themselves to that kind of ignorance, right? You're not going to cut yourself off from that possibility. You're going to try anything possible. So ram pump has potential. I'd be interested in knowing exactly what's going on inside here, right here in this metal container. Yeah, you can see the water filling up. See the water filling up the field there. Yeah, every once in a while, like a lot of these free energy devices that you see getting a lot of views and stuff on Facebook and YouTube, a lot of them are fake, but every once in a while something pops up that's real,
Once everything's perfectly organized, I'll start working on my thesis.
Ha. Yeah, I said that to myself too. Spoiler alert, never happened. Someone said, want your opinion on this. Okay. All right, someone. Let's check out what you got. Bam. Let's kick it up a notch.
Forum. If you don't. Hey, what's up? This is Jim again from Mooker.com over Unity.
Hey, Jim. This is Ben from Beneficence TV.
Forum. If you don't believe in free energy is possible, this video is not for you. For those
Well, this video's definitely for me.
who think it might be possible, I want to explain and show some demonstrations in this video of where it could come from and how I think electricity, especially induction, actually works. Where it is
Sounds good. Let's do it.
creating free energy, except harnessing it is the hard part. Okay, this is the first circuit we're going to show on a bench. Here's an AC power supply as the one source. Okay, we're going to rectify it into direct current pulses, all one polarity, which here's the positive lead, direct current coming out. Now remember, a bridge rectifier has diodes in here, so current can't flow back into the positive, it only flows one way out. Okay, when alternating current pulses are coming out, they have a choice. They could go into this diode, but they're not going to go there because they're blocked. So they're forced, these currents, to go up through a resistor first. We're going to do a resistor. At that point, there's a split. Okay, this current is going to go left because it needs to return to the source. It needs to complete the circuit. If it goes right, it goes through the current meter, through the diode, and back to the positive where a diode's blocking it. There's no completed source. There's no complete.
My bad. I was looking at chat for a second. I have to rewind that. I really want to pay attention to this.
But they're not going to go there because they're blocked. So they're forced, these current source. Okay, we're going to rectify it into direct current pulses, all one polarity, which here's the positive lead, direct current coming out. Now remember, a bridge rectifier has diodes in here, so current can't flow back into the positive, it only flows one way out. Okay, when alternating current pulses are coming out, they have a choice. They could go into this diode, but they're not going to go there because they're blocked. So they're forced, these currents, to go up through a resistor first. We're going to do a resistor. At that point, there's a split. Okay, this current is going to go left because it needs to return to the source. It needs to complete the circuit. If it goes right, it goes through the current meter, through the diode, and back to the positive where a diode's blocking it. There's no completed source. There's no completed path there. So the current coming out of this AC supply must come out this red, go up here, through the resistor, back through the blue, back through the diodes, and into the other side of the supply. So that's going to be the first test we're going to do, and I'm going to show you the results with the current meter. You will see zero current flowing through the meter with this configuration.
Right, that makes sense.
I'm going to set it up and get that part going now.
Awesome.
Okay, very basic setup. I said alternating current before, I meant direct current. Because
Oh, real quick, is this your channel or is this somebody else's channel? Because I like this video already.
Because it's direct current pulses. We have a variac putting out alternating current, two polarities. It gets rectified, okay, into single polarity pulses. Okay, our positive line comes out into one side of a resistor, goes through the resistor, and back to the diode. That's the completed circuit. On the other side, we have a red lead coming out of the negative side of the resistor, going through a direct current set amperage multimeter. Okay, direct current because it's single polarity pulses. Right, it's going to go through the multimeter and come back into a diode that only allows it to go this way. So the power supply cannot send power going into the diode this way. The anode is on this side. Okay, so we're going to turn this up to 50 volts and let this thing cook. Okay, here's the meter. Okay, we're about at 50 volts.
Generative AI is a breakthrough technology in artificial intelligence.
If you train a model with images, it will be able to generate new images.
Nothing. And this thing, oh, it's getting hot already. Nothing going through there. We'll turn it up a little more. Okay, I hear it buzzing away. Yeah, now it's piping. No currents going through the meter. Nothing flows. Ooh, it's starting to smell. Okay, good amount of current going through there. And as you saw, the multimeter stayed at 0. No current passes through there. Okay, that's number 1. Next, we're going to go back to the computer and explain the next part and show you a little different results. Okay, back to the computer. Next, we're going to do the same setup, exact same, except we're going to replace the resistor with the transformer. Okay, the secondary of the transformer is going to be on load. So there's going to be the resistor on the output of the transformer. So we know we're getting power through that resistor. We're taking power out of the circuit. Okay. In this situation, now this is going to be hard to explain and you might not understand this. In this situation, power is being created, not transformed and created. So it's called mutual induction because whatever magnetic field induces the secondary, the current in the secondary also produces a magnetic field that reinduces the primary. Okay, so there's a two-way mutual connection between these. Now, this primary coil is a load per se because current's going through it in the first circuit. But now this coil gets induced from the secondary and current enters the primary circuit from the secondary. So this coil now becomes an AC source or a power source. Now you have a circuit with two sources. Now the current that is generated from the mutual induction of this coil, in this coil, when it travels, it has two paths now. It could complete its path like this and get back to the coil because the diode's the right way and current will flow through the meter, or it could go the usual way back through the negative terminal of the AC supply and back out to positive and back to the coil. Now it has two paths. So the original input AC only has one path, this way like we just saw with the resistor. But the second source, which is going to be from the mutual induction, has two options. It could go through the usual way, through the AC supply and back to the coil, or it could go this way, through a current meter and back to the coil. So we're going to do this test and we're going to watch the current meter. Now, I'm going to give it away. You're going to see current flowing through the current meter because it works. Now, the issue is, in this configuration, without remediation, this way has absolutely no resistance because it's all the voltage on this side is at 0 and it goes right into the negative side of the source, which is extremely negative, and then it comes back out and goes through the right way. If it goes this way, it's okay at first, but now after it goes through this diode, it has impedance from the positive current coming this way and this current going this way, trying to get back. So it doesn't prefer this way because you have more blockages in the path. It prefers this way. But nonetheless, we could get some of this current, the mutual induced current from the second source, to go this way. So I'm going to demonstrate this on the video now.
Do you like having a P.O. box but are tired of wasting time?
Yeah, because I'm a shady criminal who likes having a P.O. box and not a real address.
Here, because we have more going on, but the variac, the bridge rectifier, positive comes out to the red wire, which goes into the primary of the transformer. Okay, out of the black wire out of the transformer into an alligator clip that goes back to the negative of the bridge rectifier. Direct current. Pretty simple. Okay, now the same thing. The multimeter leads, the red one's attached to the negative of the transformer. Okay, the negative of the bridge rectifier. And this one's attached to, the negative's attached to the diode that goes to the positive. So the exact same setup as before that I just showed. The secondary of the transformer is on load. Here's the multimeter measuring direct current from the negative of the transformer, or from the negative of the bridge rectifier, back to the input of the diode, which goes this way. So let's turn it on, try to bring it up to 50 volts again. Let's see. Okay, 40. I don't think I could get it up to 50 volts. Yeah, I can. 44. Okay. Under 50 volts, like 45 volts or so. I don't want to pump this up too much. Anyway, as you see, we're going into there. And now look, we have current going through the multimeter. Where is this current coming from? It's not coming from here, because as we saw with the resistor, it doesn't have a path. But there's current going through it. And I could light LEDs with it. I could fill caps. It's real current going through that. Where is that coming from? I just showed you in the picture tutorial. Now watch, I'm going to start to turn down the power. I'm turning the variac down slowly. And the power is starting to vanish. And it's off. Okay, so let's wrap this up with this horrible drawing. Here's your AC supply, just feeding a regular transformer. Alternating current, you plug a transformer into the wall outlet. It puts alternating current into the primary coil, okay? A completed circuit, right? When you connect your load onto the secondary, it creates alternating current in the secondary, which makes a magnetic field in the secondary. The secondary mutually inducts back to the primary in exact proportion. That's why the amperage goes up proportionally of your input to the load that you pull out. Because whatever you're pulling out, it's making that much of a magnetic field that induces the primary exactly that much and raises your input, because that...
Now, correct me if I'm wrong, but I do believe this is what he's saying is essentially you're creating an instability in the system. You have more power coming out of the AC than the multimeter, and it's an asymmetrical system that nature doesn't like. So nature likes to balance out those asymmetrical systems, and you end up getting free energy from the vacuum, as Tom Bearden likes to describe.
Extra power. This becomes a battery. The primary becomes a second source, and the second source always flows in the direction where it raises your current with the current coming out. So that raising of current in your primary supply is not necessarily because it's drawing more. It's because more is being pushed through it. Okay, so there should be, and I know there is, ways, like I just showed, something very small, but there is more optimal ways to take this reciprocal, not magnetic field, but reciprocal current, and instead of letting it go through the supply or through the source, thus increasing your amperage, reroute that current somehow and use that reciprocal instead of allowing it to hurt you or to raise your input. Then,
yeah, essentially what he's saying is you're using the pushback from the vacuum. You know, the vacuum, nature doesn't like that instability, and the vacuum pushes back to create more stability, to balance out the equation with more energy from the vacuum. And most of that's just wasted in these systems and labeled in traditional systems and traditional academia as instabilities, and they're just rooted out of the system as noise or back EMF that most electrical engineers are taught to ignore or to weed out of their circuits. Here, we're actually recognizing that there is a response from nature from creating this instability. When you create this instability, this response is basically, I believe at a quantum scale, you're contracting and expanding space, which essentially contracts and expands counter space, which is the vacuum, and that creates energy.
In theory, there should be more energy to harvest than the energy input into the circuit. Join the forum.
Very good video. Thank you for this video.
We believe in a future where every person...
That was rude. I was talking. As I was saying. Very good video. Thank you for that. We're going to move on to something that Mike posted a few minutes ago. I know, I'm sorry, Mike, I didn't get a chance to get to it earlier, but, you know, this was a really cool video. I did see it, and I did write it or copy it down here, so I'm going to put it in there. The presenter. Let's present this. Get rid of that. Okay, this video is called The Laser Tape.
In May of 1989, a local Las Vegas news station, KLAS-TV, aired an explosive interview with an anonymous physicist filmed in silhouette. This individual claimed to have worked at a secret military installation hidden in the Nevada desert, where he was tasked with back engineering an antimatter reactor from an alien craft. A subsequent interview with the station's lead investigator, George Knapp, revealed the identity of the mysterious physicist, one Bob Lazar. The story that Lazar told and that Knapp publicized ignited a firestorm of intrigue around the globe and, for the first time, put Area 51 on the map. Lazar's extraordinary claims have been hotly contested over the years, even by respected ufologists such as the late Stanton Friedman, himself a nuclear physicist, who insisted that the whole thing was a fairy tale. However, despite intense scrutiny, Lazar's story has never been
crazy. Look at this guy. Look at how crazy he looks. He's like, mwah. He just looks nefarious. Like I'm gonna do some evil crap and get away with it too, pesky kids.
That the whole thing was a fairy tale. However, despite intense scrutiny, Lazar's story has never been successfully debunked. To the contrary, it continues to gain credibility with each passing decade. Recent testimony from an intelligence community whistleblower, David Grush, confirmed the existence
the science
of a
adds up. Now, I'm skeptical of David Grush. You know, as Dr. Greer has said himself, he is an information agent, right? He has a history in espionage and disinformation, specifically disinformation campaigns. But Grush aside, Bob Lazar has some very legitimate claims, and we've seen these claims being proven over time, multiple times over time. And the science adds up, you know. He says that some of these craft, they fly belly up, you know, which aligns with some of the science that we've seen. He says they produce a corona discharge, which aligns with some of the phenomena we've seen with anti-gravitic devices such as the Graviflyer.
Legacy crash retrieval program, the purpose of which is to recover and reverse engineer alien craft. In other words, non-human hardware and bodies have been and are being systematically recovered from UFO crash sites by elements of the United States military under the purview of special access programs directed by defense aerospace contractors, such as Lockheed Martin, and whatever outfit Lazar was working for. Bob Lazar's incredible story is well documented in his autobiography, Dreamland, which is a fascinating read that I highly recommend. Thanks to Joe Rogan, many people are becoming increasingly familiar with the Lazar saga, but few are aware that shortly after coming forward with his claims, Bob and his associate Gene Huff made a video describing the physics that power the alien craft. Entitled The Lazar Tape, the content of the video is very well presented and conveys, in my opinion, critical information about the nature of the UFO phenomenon that is often overlooked by people interested in the topic. The Lazar Tape has become rather difficult to find online, so I've decided to feature it in this video. But before you watch it, I want you to consider some of the highlights from Lazar's testimony. The secret military base where Lazar was employed, the S4 installation, is located in central Nevada, about 15 miles south of Area 51, near the Papoose Dry Lake. This is important because previous to Bob's claims, Area 51 was virtually unknown to the public. After his claims, many people have observed and filmed UFO activity in this region, and some, such as the late John Lair, precisely at the time and place indicated by Bob, which reinforces the veracity of his testimony. The S4 installation was allegedly equipped with 9 hangar bays built into the base of a mountain, each one housing an alien disc of unique design. Some of the discs appeared to be non-functioning crash retrievals with visible damage to their hulls. Lazar was hired to work with one of the functioning models, which he nicknamed the sports model due to its compact size and sleek exterior. Specifically, he was assigned to the team experimenting with the craft's antimatter reactor. The sports model saucer was clearly not designed for adult human beings, but persons of diminutive stature, such as children, or more precisely, gray aliens. The antimatter reactor that powered the alien craft employed a machined fragment of exotic matter called element 115, which is not naturally occurring on planet Earth. It's important to note that for years, skeptics laughed at Lazar's claim that a hitherto...
So here's a little something that is a unique theory and a unique take on the Lazar experience that I don't think you'll find anywhere else. And this goes back to the idea that you can actually create energy out of the vacuum very easily with just basic geometry, right? And if it's that easy to create energy, why would you need fuel for your craft? So, and then I'm going back and I'm watching Lazar's testimony, and he describes a light chamber experiment where the element 115 sample actually bends light. Now, this is where things get interesting. I think that since energy is so easy to be pulled out of the vacuum and you don't really need a fuel source, so to speak, and if you were an advanced civilization traveling from galaxy to galaxy, intergalactic civilization, you would think that you would have that knowledge. Now, what would you use the fuel for? You could use the fuel as a source for bending light around the craft as a stealth mechanism. So it's my theory that the element 115 wasn't used as a fuel source for the craft's actual propulsion, but element 115 could have been the fuel source that was generating the cloaking mechanism for the craft. Interesting.
hitherto unknown heavy metal from an alien planet was being incorporated into the technology of flying saucers until 2003, when element 115, moscovium as it is known today, was synthesized by scientists at the Joint Institute for Nuclear Research in Dubna, Russia. Although the isotope synthesized by the Russians was highly unstable and not the same as the one utilized in the alien antimatter reactor, it serves to demonstrate that Lazar knew about element 115 decades before it was added to the periodic table. Element 115 has some unusual properties that facilitate a matter-antimatter collision within the reactor. The immense energy.
Yeah, I know we had a gentleman on one of the Free Energy Fridays podcast. I forget his name, but he was doing research, and he said that there's 2 or maybe even 3 different types of gravity or aspects of gravity, you know, which makes sense.
Generated from this collision is used to amplify and
Lazar himself describes 2 components to gravity, a component A and a component B. I'm not, in what context, I'm not really sure, but it's interesting to think about because, you know, everything has balance in the universe, so the incommensurability.
And focus gravity waves, and this provides the aliens with the means for both anti-gravity terrestrial aviation and interstellar travel. It also explains how UFOs can move through the ocean as effortlessly as they do through the atmosphere.
You know, Malcolm Bendel also describes the orichalcum from the ancient texts as a spent cold fusion reactor fuel of Atlantis. And now this gets me wondering also if element 115 is maybe some kind of similar spent cold reaction or cold reactor fuel, you know, like not that they used it, but it was the leftover bits of what the reaction was doing, and we're just completely misunderstanding everything.
They're not actually moving through the medium of the air or the water, but rather warping the fabric of space-time around the craft. So the medium is irrelevant. The physics are the same. Lazar had the opportunity to observe the sports model disc in operation on at least one occasion and was able to confirm that his theory about how it functions was generally correct. He noted that when fully energized, the gravity wave distortion of space-time around the craft rendered it invisible from most vantage points. The fact that UFOs can disappear has led to wild speculation about supernaturalism and interdimensionality. But when we consider the physics elucidated by Lazar, it is evident that the craft disappears because gravity bends light, not because it is non-physical or phases into a different dimension. The alien craft and the beings that pilot them are physical entities. Now, I have a lot more to say about the implications of Lazar's testimony, but I'm going to reserve that commentary for my members community. So to access the rest of this video and many
Yeah, so I'm not going to play the whole video. We're going to, because I know most of this already. You know, I know the Bob Lazar story pretty intimately. But there is a good chunk here that looks like there's a testimony from Bob Lazar that I don't think I've seen. So maybe we'll watch that and then we'll end it.
You know more about interstellar travel than almost anyone else in the world, but you'll learn non-technological backgrounds. So let's begin.
I might have seen this a long time ago.
At the beginning of this first section, I'm going to give you 3 short science lessons, and once you've learned them, you'll not only know more about interstellar travel than almost anyone else in the world, but you'll know the actual method another civilization has used to travel from another star system to the planet Earth. Now, during the course of this, I'm going to have to relate information that I've learned at S4 to information that we're already aware of. And when I say we, I mean the general mainstream scientific community. So as not to waste too much time explaining established scientific facts and theories, when I say we know this or we know that, please feel free to consult any qualified scientist, professor, or science teacher to have them explain my statements to you. One of the most predominantly asked questions is, how is it possible to cross vast expanses of space without exceeding the speed of light? Or how can you travel in reasonable time and economy between points that are light years apart? Now keep in mind that the speed of light is 186,000 miles a second, which translates into roughly 669 million miles an hour. And a light year is a distance traveled in 1 year at the speed of light. Proxima Centauri, which is the star system nearest ours, would take 4 years to reach traveling at the speed of light. So up until now, when we've examined the requirements to travel these distances, we've always had to consider the problems of traveling at a speed near the speed of light. This poses problems with propulsion, navigation, fuel capacities, and even when you consider the effects of acceleration on space-time, which include time dilation, mass increase, length contraction, and a whole host of other things, it quickly becomes evident that this type of travel would require a level of technology that man has not yet achieved. The truth of the matter is that traveling these distances does require a level of technology that man has not yet achieved. But it has nothing to do with flying in a linear mode near the speed of light. We know that the shortest distance between 2 points is a straight line, so in our universe we've always assumed that the fastest way from point A to B was to travel in a straight line at the speed of light. Well, the fact is that when you're dealing with space-time and you enjoy the capability of generating an intense gravitational field, the fastest way from point A to B is to distort or warp or bend the space-time between point A and B, bringing point A and B closer together. The more intense the gravitational field, the greater the distortion of space-time and the shorter the distance between points A and B. Most of us think of space-time as the void or as nothing. And remember, it wasn't that long ago that man considered the air in our atmosphere to be nothing. Yet with time, we've become aware of the elements and properties of the air in our atmosphere. Well, indeed, space-time is an entity, and one of its properties is that it can be distorted or bent by a gravitational field. We know that gravity bends or distorts space-time and light by virtue of the fact that we're able to see stars which we know should be blocked from our view by the sun. Referring to the graphic here, the solid line denotes the position of a star that's located behind the sun, and the dotted line shows its position as viewed from Earth. This is made possible because the sun's gravitational field distorts the space-time and light around the sun, allowing us to view stars which should be hidden from view. We know that gravity distorts time by virtue of the fact that if we take two identical atomic clocks and keep one at sea level and take the other one up to a high altitude, when we bring them both back together, they reflect different times. The difference in this passage of time is caused by the fact that a gravitational field weakens the further you get from the source. So the atomic clock which was taken to the high altitude was exposed to a less powerful gravitational field than the clock which we kept at sea level. The effect of a gravitational field on space-time is something that we've been able to observe, but not to experiment with. This is due to our inability to generate a gravitational field. And up until this point in time, great mass such as a star, planet, or moon was the only source of a discernible gravitational field that we're aware of. So just as the gravitational field around great mass such as a planet distorts space and time, any gravitational field, whether naturally occurring or generated, distorts space and time in a similar manner. Now, the great benefit of generating an intense gravitational field is not only can you turn it on, but you can turn it off. If we refer back to our original...
Yes, I agree. This is an amazing explanation. And, yeah, let's continue. This is very interesting.
Illustration of space-time distortion, we can see that when we generate an intense gravitational field, we can distort the space-time and in turn the distance between the point where we are and the point where we want to be. We can then position ourselves at the point where we want to be and then stop generating the gravitational field, allowing space-time to return to its natural form. In this manner, we can travel great distances with little linear movement, and this is how space-time distortion translates into reduced distance. Now back to our original question. How is it possible to cross the vast expanses of space required for interstellar travel without exceeding the speed of light? This is accomplished by generating an intense gravitational field, distorting space-time and allowing you to cross many light years of space in little or no time and without traveling in a linear mode near the speed of light. The next question is, how do you generate a gravitational field? Up until this point in time, I've used the term generate to describe the capability of producing a gravitational field, but since I'm not aware of any way of creating a gravitational field from nothing, a more accurate term might be to access and amplify a gravitational field. And this is what I mean when I use the term generate. To understand how gravity is generated or accessed and amplified, you must first know what gravity is. There are two main theories: the wave theory, which states that gravity is a wave, and the currently accepted theory of gravitons, which are alleged subatomic particles that perform as gravity, which is total nonsense. Well, gravity is a wave, and there are two specific different types of gravity: gravity A and gravity B. Gravity A works on a smaller micro scale, while gravity B works on a larger macro scale. We are familiar with gravity B. It is the big gravity wave that holds the Earth as well as the rest of the planets in orbit around the Sun, and holds the Moon as well as man-made satellites in orbit around the Earth. We are not familiar with gravity A. It is the small gravity wave which is the major contributory.
Yep. The idea of gravitons and, the Higgs boson particle being the ultimate answer to gravity is complete BS.
Force that holds together the mass that makes up all protons and neutrons. Gravity A is what is currently being labeled as the strong nuclear force in mainstream physics, and gravity A is the wave that you need to access and amplify to enable you to cause space-time distortion for interstellar travel. To keep them straight, just remember that gravity A works on an atomic scale, and gravity B is the big gravity wave that works on a stellar or planetary level. However, don't mistake the size of these waves for their strength, because gravity A is a much stronger force than gravity B. You can momentarily break the gravity B field of the Earth simply by jumping in the air. So this is not an intense gravitational field. Locating gravity A is no problem because it is found in the nucleus of every atom of all matter here on Earth, and all matter anywhere else in our universe. However, accessing gravity A with the naturally occurring elements found on Earth is a big problem. Actually, I'm not aware of any way of accessing the gravity A wave using any Earth elements.
See, that makes sense. Gravity is holding together subatomic particles in the same way that gravity is holding together planets and solar systems. It's fractals. And even magnets are a specific kind of gravity.
Whether naturally occurring or synthesized, and here's why. We've already learned that gravity A is the major force that holds together the mass that makes up protons and neutrons. This means the gravity A wave we are trying to access is virtually inaccessible, as it is located within matter, or at least within the matter that we have here on Earth. However, the Earth is not representative of all matter within our universe. The residual matter which remains after the creation of a solar system is totally dependent on the contributing factors which were present during the creation of the solar system. This is true whether you believe that the origin of the universe was an evolutionary event or that a supreme being caused this event to happen. The two main factors which determine what residual matter remains after the creation of a solar system.
That right there is the atheist logical fallacy. Why can't they both be the same? Or why can't both be an option? That's the false dichotomy dilemma. We only have one option or the other. No, what if it was intelligently designed and evolved at the same time? Come on, think outside the box here.
System are the amount of electromagnetic energy and the amount of mass present during the solar system's creation. Our solar system has one star, which is our sun, but the majority of solar systems in our Milky Way galaxy are binary and multiple star systems. In fact, many single star systems have stars that are so large that our sun would appear to be a dwarf by comparison. Keeping all this in mind, it should be obvious that a large single star system, binary star system, or multiple star system would have had more of the prerequisite mass and electromagnetic energy present during their creations. This makes it possible for these systems to possess elements which are not native to the Earth. Scientists have long theorized that there are potential combinations of protons and neutrons which should provide stable elements with atomic numbers higher than any which appear in our periodic chart, though none of these heavy elements occur naturally on Earth. 88 of the first 92 elements on the periodic chart occur naturally on Earth. Some heavier elements do occur in trace amounts, but for the most part we synthesize these heavier elements in laboratories. Generally speaking, the stability of these synthesized heavy elements decreases as their atomic number increases, but experiments at the Lab for Heavy Ion Research in Germany have shown that this may only be true up to a certain point, as the half-life for element 109 is longer than that of element 108. The point is that our observations and theories are accurate. The fact is that heavier stable elements with higher atomic numbers, which have more protons, neutrons, and electrons than any Earth elements, do exist. However, up until this point in history, there has been no physical evidence to prove this. But now that proof is here. The most important attribute of these heavier stable elements is that the gravity A wave is so abundant that it actually extends past the perimeter of the atom. These heavier stable elements literally have their own gravity A field around them, in addition to the gravity B field that is native to all elements. No naturally occurring atoms on Earth have enough protons and neutrons for the cumulative gravity A wave to extend past the perimeter of the atom so you can access it. Even though the distance that the gravity A wave extends is infinitesimal, it is accessible, and it has amplitude, wavelength, and frequency just like any other wave in the electromagnetic spectrum. Once you can access the gravity A wave, you can amplify it just like we amplify any other electromagnetic wave. To demonstrate how a wave is amplified, we can use this oscilloscope, and as you can see, it graphically depicts the tone you hear as a wave. As we amplify the tone, you can see that the size or the amplitude of the wave increases, giving us a more powerful version of the same identical wave, and thus the tone sounds louder. In like manner, the gravity A wave is amplified and then focused on the desired destination to cause the space-time distortion required for space travel. This amplified gravity A wave is so powerful that the only naturally occurring source of gravity that could cause space-time to distort this much would be a black hole. This brings us back to our original question: how do you generate a gravitational field? You must have access to an element which is heavy enough for the gravity A wave to extend past the perimeter of the atom. Then you can access and amplify it for space-time distortion. To complete our 3 science lessons, the last question is, what is the power source for this type of travel? Well, for those of you with limited knowledge about power sources,
I'm just going to pause here real quick and say that's where I disagree with Bob Lazar. It may be a way to generate a gravitational field, but as we've seen in other anti-gravitic devices, like T. Townsend Brown device and the Searle effect generator, there's multiple ways to skin this cat. And I believe torsion fields, if you can create a torsion field in whatever way that's possible, you can create a gravitational wave useful for propulsion. And I believe that's what the Graviflyer does. But yeah, the torsion field is important too. And he's saying that a heavy element is required. Not necessarily. I mean, if you read the ancient Vedic texts, they clearly describe flying machines that were run on counter-rotating vortexes of Mercury. So, food for thought.
I'm sure you can probably imagine the enormous amount of power required to cause a space-time distortion for this type of travel. After all, we're amplifying a wave that barely extends past the perimeter of an atom until it's large enough to distort vast amounts of space-time. For those of you with extensive knowledge about power sources,
so it looks like we have a very cool update. Here, let me go on, enable the camera. Where is it? There you are, you little dirty jerk. Okay, so Mike K from Faraday Research just invited me to a live stream, so I think he's doing a live stream tonight, guys. We might be doing a League of Extraordinary Inventors tonight. So if that's going on, then we're going to cut to an intermission and wait for that, because that's going to probably be on at 9. I'm going to double check with him. Let me play this and go over some things, and we'll probably cut to an intermission, and then...
I'm sure it's probably even more puzzling as to how it's possible to have a compact, lightweight, onboard power source that can provide this much power. For everyone to understand that, I need to further explain a couple of things we briefly touched upon in the last question. If you remember, I said that for the most part, we synthesize or create heavier elements in accelerators, and their stability decreases as their atomic number increases. So what does this all mean? Well, we synthesize these heavier, unstable elements by using more stable elements as targets in a particle accelerator. We then bombard the target element with various atomic and subatomic particles. At this point, transmutation occurs, making the target element a different, heavier element. This element now has a higher atomic number, as the atomic number simply indicates the number of protons in the nucleus of the atom. So this is what I mean when I say their atomic number increases. What does their stability decreases mean? The length of time which an element exists before it decays determines its stability. Atoms of some elements decay faster than atoms of other elements, so the faster an element decays, the more unstable that element is considered to be. When an atom decays, it releases or radiates subatomic particles and energy, which is the radiation that a Geiger counter detects. As you can see, this Geiger counter is detecting the radiation from this uranium, which literally means that the Geiger counter is sensing the subatomic particles which are being released or radiated as the uranium decays. Those elements in which nuclear radiation can be consistently detected are radioactive elements. These heavy elements, which we synthesize in particle accelerators, are of the radioactive variety, and they decay very rapidly. Since we're only able to make a few atoms of these elements, and because they decay so rapidly, we're not able to observe much about them. This is what I mean when I say their stability decreases. However, there are elements with higher atomic numbers which are stable, even though they don't occur naturally on Earth, and we can synthesize them in particle accelerators. These are the elements in the 114, 115 range which don't appear on a periodic chart. Beyond element 115, the elements become unstable again, and in fact, element 116 decays in fractions of a second. This finally brings us to the power source. The power source is a reactor which uses this element 115 as its fuel. In this reactor, element 115 is used as a target and is bombarded with protons in a small particle accelerator. When a proton plugs into the nucleus of an atom of 115, it increases its atomic number and becomes an atom of element 116, which, remember, decays instantly. What element 116 releases as it decays, or what it radiates, is antimatter. What is antimatter? Antimatter is the exact counterpart of matter, which has a charge and a spin that is in the opposite of all matter. When combined with any matter in our universe, antimatter reacts and completely converts to energy. And remember, the rapid conversion of matter to energy is what we generally call an explosion. To demonstrate the explosive power of antimatter, let's pick a random area where an atomic bomb might explode. Oh, let's say Iraq. And for demonstration purposes, let's say an atomic bomb would explode, for instance, in, Baghdad. Well, if one of our older atomic bombs exploded in Baghdad, the area of total devastation, which is indicated by the red dot on the map, would be approximately 2 miles. This would be caused by a fission reaction in which less than 1% of the nuclear material is converted to energy. Most of you are familiar with the bombs that were dropped on Japan in World War II. This is the same bomb that was dropped on Nagasaki August 9, 1945. About this same time, Dr. Edward Teller, who's known as the father of the hydrogen bomb, figured out that a nuclear fusion bomb was possible. Fusion would release even more energy and cause an even bigger explosion from the same amount of nuclear material. The Japanese surrendered, we never dropped the hydrogen bomb, and Dr. Teller's been in a bad mood ever since. But if a hydrogen bomb containing the same amount of nuclear material as the Nagasaki bomb were to explode in Baghdad, The area of total devastation would be approximately 20 miles. This would be
at 9 o'clock, so stand by. I believe we're having the League of Extraordinary Inventors podcast tonight, so it's going to be amazing. It should be around 9 Eastern Standard Time, I believe.
Again, less than 1% of the nuclear material actually converts to energy or explodes.
Oh, this will be here. Yeah, I'll be streaming it here. No need to post a link. I mean, if you want to subscribe to the other Inventors channels, I'll be posting those links as well during the show. But yeah, this will be here. This is the intermission, and then just stay here, and we'll switch right over to StreamYards. I have that ability. I'm kind of a producer in that respect, so stand by.
The other 99% of the nuclear material on this type of bomb is dispersed, but is not involved in the actual nuclear fusion reaction. Now, if a bomb was made with the same amount of nuclear material as the Nagasaki bomb, and that material was antimatter, when that bomb exploded in Baghdad, the area of total devastation would include parts of Africa, Europe, and Asia, with the exact area of total devastation being very difficult to calculate. This would be caused by a total annihilation reaction, which is the complete conversion of matter to energy. 100% of the nuclear material on this bomb would explode or convert to energy. We currently have no practical way to harness antimatter into a bomb, and generally speaking, we can only isolate antimatter in a particle accelerator and store it for a short time. This demonstrates the enormous amount of power released when you totally convert matter to energy, which is what happens when antimatter and matter are combined. So back to our power source. Inside the reactor, element 115 is bombarded with a proton, which plugs into the nucleus of the 115 atom and becomes element 116, which immediately decays and releases or radiates small amounts of antimatter. The antimatter is released in a vacuum into a tuned tube, which keeps it from reacting with the matter that surrounds it. It is then directed towards a gaseous matter target at the end of the tube. The matter and antimatter collide and annihilate, totally converting to energy. The heat from this reaction is converted into electrical energy in a near 100% efficient thermoelectric generator. This is a device that converts heat directly into electrical energy. Many of our satellites and space probes use thermoelectric generators, but their efficiency is very, very low. All of these actions and reactions inside of the reactor are orchestrated perfectly like a tiny little ballet. And in this manner, the reactor provides an enormous amount of power. So back to our original question. What is the power source that provides the power required for this type of travel? The power source is a reactor which uses element 115 as a fuel and uses a total annihilation reaction to provide the heat which it converts to energy, making it a compact, lightweight, efficient onboard power source. I've got a couple of quick comments about element 115 for those of you who are interested. By virtue of the way it's used in the reactor, it depletes very slowly, and only 223 grams of 115, which is just under half a pound, can be utilized for a period of 20 to 30 years. Element 115's melting point is 1740 degrees Celsius. I need to state here that even though I had hands-on experience with element 115, I didn't melt any of it down, and I didn't use any of it for 20 to 30 years to see if it depleted. So we've learned how space-time is distorted by a gravitational field, we've learned how that gravitational field is generated, and we've also learned where you get the power to accomplish all of this. Now it's time to link all we've learned in our science lessons to the vehicle that utilizes all of this technology. And a few years ago, I never thought I'd hear myself say this, but that vehicle is a disk, which is generally referred to as a flying saucer. I had at least partial views of the 9 different disks out at Area S4, but the one I'm going to describe to you now is the one in which I not only saw 2 of the 3 interior levels, but I also saw it fully functional in flight. And no, unfortunately, I didn't get to go for a ride in it. This particular disc appeared to be in excellent condition, and because of its sleek appearance, I nicknamed it the Sport Model. The Sport Model is about 16 feet tall and 40 feet in diameter. The exterior skin of the disc is metal, which is the color of unpolished stainless steel. The Sport Model sits on its belly when it's not energized. As you can see, the hatch is located on the upper half of the disc with just the bottom portion of the door wrapping around the center lip of the disc. The interior level of the disc is divided into 3 levels. The lower level is where the 3 gravity amplifiers and amplifier guides are located. These are the things used to amplify and focus the gravity A wave that we learned about in our science lessons. The reactor is located directly above the 3 gravity amplifiers on the center level and is in fact centered between them. The reactor is similar to this half-scale model. The element 115 is machined into triangles like this and is then inserted into the reactor. This piece of element 115 is the source of the gravity A wave as well as the target that is bombarded with protons to release the antimatter, both of which we learned about in our science lessons. The center level of this disk also houses the control consoles and seats, both of which were too small and too low to the floor to be functional for adult human beings. The walls of the center level are all divided into archways. At one point in time, when the disk was energized, one of the archways became transparent and you could see the area outside of it just as if the archway was a window. After the panel had been transparent for a while, a form of writing, which was unlike any alphabetic, scientific, or mathematical symbols I've ever seen, began to appear on the transparent archway. And I was never informed as to how all of this was achieved, not that any of that would have required alien technology. I was never given access to the upper level of the disk, so I can't enlighten you as to what the porthole-like areas are, other than I can assure you that they're not portholes. Now, before I go any further about the disk, I'm going to show you where and under what circumstances I saw it tested. My job in this program was to be part of a back engineering team. Back engineering is the act of taking a finished product and tearing it apart to find out what makes it tick. The goal in this program was to see if the technology of the disk could be duplicated with Earth materials. When I went to work, I was flown from McCarran Airport in Las Vegas to Area 51, which is a highly secure government base on the Nevada test site. Area 51 is located about 125 miles north of Las Vegas near the Groom Mountains and the Groom Dry Lake bed. From Area 51, I was bused to an even more highly secure facility located about 15 miles south of Area 51 called S4. S4 is situated at the base of the Papoose Mountains by the Papoose Dry Lake bed. The airspace around S4 is restricted, and if any unwelcome aircraft strays into the outer sector, they radio the pilot and instruct him or her to leave. If that pilot continues and strays into the middle sector, jets will be scrambled to escort the intruding aircraft out. If for any reason whatsoever that aircraft penetrates into the inside sector before jets can be airborne, ground-to-air missiles will neutralize the intruder. The moral of this story is don't try and fly into S4. The S4 installation is built into the mountain and the 9 hangar doors are angled at about 60 degrees. These doors are covered with a sand-textured coating to blend in with the side of the mountain and the desert floor. As you can see in this representation, my ID badge had a white background with 1 light blue and 1 dark blue diagonal stripe in the upper left-hand corner. At the bottom of the badge, there were letters and numbers designating various areas, stripe running down one side. The hangar that housed the sport model was like a typical airplane hangar with the exception of the angled doors that I mentioned before. The hangar was equipped with typical tools and extensive electronic equipment. It also had a machine with an X-ray emblem on it and an overhead crane rated at 20,000 pounds. Equipment in this hangar was marked with a black number 41 with a white circle around it. It was outside of this hangar that I saw the sport model tested. Now, when the disk travels near another source of gravity, such as a planet or moon, it doesn't use the same mode of travel that we learned about in our science lessons. When a disk is near another source of gravity, like Earth, the gravity A wave, which propagates outward from the disk, is phase shifted into the gravity B wave, which propagates outward from the Earth, and this creates lift. The gravity amplifiers of the disk can be focused independently, and they are pulsed and do not stay on continuously. When all 3 of these amplifiers are being used for travel, they're in the delta configuration, and when only one is being used for travel, it's in the omicron configuration. As the intensity of the gravitational field around the disk increases, the distortion of space-time around the disk also increases. And if you could see the space-time distortion, this is how it would look. As you can see, as the output of the gravitational field from the amplifiers becomes more intense, the form of space-time around the disk not only bends upward, but at maximum distortion actually folds over into almost a heart shape around the top of the disk. Now remember, this space-time distortion is taking place 360 degrees around the disk. So if you were looking at the disk from the top, the space-time distortion would be in the shape of a donut. when the gravitational field around the disk is so intense that the space-time distortion around the disk achieves maximum distortion and is folded up into this heart-shaped form, the disk can't be seen from any vantage point, and for all practical purposes is invisible. All you could see would be the sky surrounding it. The program out at Area S4 consisted of 3 projects: Project Galileo, Project Sidekick, and Project Looking Glass. Project Galileo dealt with gravity propulsion and was the source of all the information you've learned in this first section. Project Sidekick dealt with a beam weapon that had a neutron source and was focused by a gravity lens. Project Looking Glass dealt with the physics of seeing back in time. Now, I was not personally involved with the hardware of Project Sidekick or Looking Glass, and those projects are beyond the scope of this video. So this brings us to the end of this first part, in which I'm presenting to you as fact. At this point, we begin our second part, which is the section that contains what I call excerpts from the government Bible. I call it that because, as you can tell from part 1, there's a small segment of the United States government that makes scientific and technological judgments from a knowledge base that is not available to the general public. If the following information is true, the United States government also makes judgments on a historical, philosophical, and even theological level from a knowledge base that is not available to the general public. These are excerpts from some of that information. As part of my indoctrination into the program at S4, I would randomly be taken into a small room which contained a table, a chair, and 120 or so briefings in blue folders. I'd be left there to read for varying amounts of time, usually about half an hour. These briefings contained a wide spectrum of information, mostly relating to aliens and alien technology. These reports appeared to be an overview of alien information which can be used to brief scientists from any field about the scope of the whole project, and not just their specific field of endeavor. The overview of Project Galileo was accurate. I read the overview and later witnessed evidence which proved it to be accurate. So it is possible that scientists involved with other projects could have seen evidence that these other overviews were also accurate, but I can't make that assertion. To me, these reports were simply words on paper. So to keep from saying allegedly and supposedly in every sentence, I'll relay this information to you as I read it, since I've already put this disclaimer on it. This technology that you've learned about thus far was brought here by some alien beings from the Zeta Reticuli 1 and 2 star system. These stars are located in the constellation of Reticulum, which can only be seen from the southern hemisphere. Zeta Reticuli is a binary star system, which means it has 2 stars, and is located approximately 30 light years from Earth. These beings are from Reticulum 4, which is the 4th planet out from Zeta Reticuli 2. This is the way star systems were referred to in these reports. They simply designate the name of the star and the number of planets from the nearest to the furthest from the star. For instance, our Sun was designated as Sol, and the Earth was referred to as Sol 3 because we're the 3rd planet out from the Sun. A day on Reticulum 4 is 90 Earth hours long. The beings are 3 to 4 feet tall and weigh 25 very slight nose, mouth, and ear positions and are hairless. Any dates in the information regarding these beings were written in a 6-digit number which began with 1623. Since I had no idea what the 6-digit number was for the present year, I had no way of calculating when these beings arrived, or at least arrived this time. These beings said that they had been visiting Earth for a long time and presented photographic evidence which they contended was over 10,000 years old. There was an exchange of hardware and information in Central Nevada until 1979, at which time there was a conflict which brought the program to an abrupt halt. The beings left, but were to return at a 1623 date, and I don't know what that date is. With the remaining hardware and information, the U.S. government started the back engineering program. In May of 1987, some scientists took an antimatter reactor to an underground blast facility on the Nevada test site to perform an experiment. Unfortunately for them, their experiment required them to cut the reactor open, which resulted in their deaths. This explosion was explained to others at the test site as a previously unannounced low-yield underground nuke test. I was hired in December of 1988 to replace one of these men. These beings conveyed information about the capability of affecting the human brain to anesthetize the human body. This is done without any physical contact from a remote source. For this anesthesia to be accomplished, the brain has to be in a relaxed state similar to that required for hypnosis. If the brain is subject to any external stimulation like stimulant drugs or loud music, this manipulation of the nervous system is ineffective. These beings said that man was the product of externally corrected evolution. They said that man,
Hey,
as a
Ben.
species, had been genetically
Your,
altered
mic is,
65 times.
muted there.
They refer to humans as containers, yet I don't know what we're containers of. As I'm sure you now know, it was impossible for me to corroborate the information in the
He's probably
second
still
section.
on his stream right
And
now.
obviously, if this
Oh, he
information
can
is
do it.
true, the ramifications are far-reaching, and you don't have to be a nuclear physicist to figure that out. So before I bring this to an end, there are a couple of questions I should address for you. The first one is, how did I get into this program?
Get everything sorted out.
While working at Los Alamos National Lab in 1982, the local newspaper did a front-page story on a jet car I had built. Coincidentally, Dr. Teller was giving a speech in Los Alamos that same day.
Yeah, more money out of my
We met and had a short chat about the jet car, and I later listened to his speech.
I hate that.
never met Dr. Teller again, but in 1988, when I decided to
I
re-enter
gotta
the
go get a
scientific
tire patch
community, I
this
sent him
week,
a
too.
resume and inquired about a job.
My truck got a
Dr.
screw
Teller
in it,
responded
so
by telephone and
the
told me
front
that he was
tire.
no longer active,
Yeah, I've had a
but
few
just
of
functioned in a consultant capacity. He gave me the name of a contact to call
Sad thing
in
is,
Las
it looks
Vegas.
like one of my screws.
I made
So,
that call, and things progressed
probably
from
do it
there
to
until I
myself.
got into the program. I never got a chance to
Yeah,
ask Dr.
sometimes if you
Teller
go
if he
through a
remembered me from
construction
Los
site or
Alamos,
near
so I
one,
don't know if
you-
that was a factor or not.
If you use nuclear
probably
fuel,
my front
not
yard.
that possible. Nuclear fuel is feasible, but whether these eventuate velocities are feasible, which are interesting, if you ever want to get there, let's start. That is an important question. And that's about all I can say. All I have time to say. And what specifically the fuel will be, I think it might be fission, more probably fusion. And it won't come soon.
Is there any other nuclear reaction besides fission and fusion that you know of?
No.
Is there anything such?
Look, please, you try to explore the things about which I only will have to tell you it is not interesting, it's a waste of time.
Above plutonium or
Look, it is, in my opinion, not interesting. I don't intend to answer it. If you ask me that question on camera, I will shut up. I will sit silent. You're not going to get an answer out of me on that.
Okay. And if I ask you on camera if you know Bob Lazar, can you just say no?
I will sit silently.
The second question is that if all I've just presented to you is true and the government is keeping this a secret, how can I make a video telling you about it? Well, the bottom line is, if there are any repercussions from making this video, it would simply confirm that what I told you is true. So what you do with this information is up to you. Remember, not everyone who sees a disc in the sky is crazy, so keep your eye on the sky, especially here in central Nevada, and thanks for listening.
Imagine a world where time travel is no longer confined to the realms of science fiction.
Time travel. It's possible, sir.
Where do you come from?
I'm from the past.
Imagine being able to plant crops in the morning and then harvest those crops that very night. Or how about healing a wound with a localized time acceleration device? A device that can speed up time in a small focused area, reducing the time it takes to heal wounds. Take a moment with me to imagine this world. A world where time is no longer a constraint, but a tool. Remember Back to the Future? The flux capacitor is a fictional device from the Back to the Future movie franchise that was used to achieve time travel. According to the movies, the flux capacitor is powered by plutonium and generates the 1.21 gigawatts of electricity needed to create a temporal displacement field. Sounds like a giant load of fiction, right? The truth is actually a lot stranger than fiction. Let's explore further.
You told me the whole story. You were standing on your toilet and you were hanging a clock and you fell and you hit your head on the sink. And that's when you came up with the idea for the flux capacitor, which is what makes time travel possible.
Hey, Scott!
Hello, everyone. Welcome to Beneficence TV Live.
No, no, literally, you walk out the door, you have enough driveway space for one car, and you're on the street after that.
You guys have a lot of land up there.
There's no land. They don't give you any land. They
Oh,
box everybody. They boxed everybody in like sardines.
Yeah.
Houston here, we have a lot of land.
Like I live in the old part of Milton, and the houses here are back from like the 60s, 70s, and 80s. They actually have a property where if you go into the south end of Milton, where I was living at one point, there's no land. You got a house, you got enough for a driveway, and that's it. Your backyard, maybe 10 feet from the back door. That's it.
Wow.
That's all you get.
See, like here, like $1.5 million, let's say in the inner city, will bring you about half an acre. You know, 1/3 to half.
See, that's totally different in Houston. Houston is like the way it was here 30 years ago. Okay, the way the houses are built. Like my brother, he lives more north than where I live, so he lives at the edge of his town, and he's got a half acre of land, or just shy of an acre, and for the same price, right?
Yeah.
But you go into anywhere closer to the GTA, you're going to get a big house, but you're going to have no property.
Yeah.
So it's a trade-off. One thing for
exactly. Yeah. Exactly. All right. It is 9:02. We're going to get the show on the road, and yeah, stand by. Good evening, everybody. Welcome to League of Extraordinary Inventors. I'm your host, Mike from Faraday Research. It is August 16th, 2024. Welcome to the show. It's Friday night, Free Energy Friday. And we got a regular panel on tonight. Got Nathan, and we have Benefactor with us. We also have Noelle, or we call her Lulu. And we have Mike from Florida. Welcome to the show. Okay. How's everybody doing?
How you doing?
Good.
Hi.
Excellent. Everybody
Good
had
to
a
be
good
here,
week?
Mike.
Yep. Well, it's Friday night. Of course, it's good to be here.
Oh yeah.
Right?
It's the favorite. It's my favorite day of the week.
Exactly.
Yeah.
Happy Friday, Free Energy Friday, whatever you want to call it. Sounds good to me.
Nice.
hopefully we'll get Philip on. Maybe he's just running a little bit late, so we got one more spot for one more person to join us. Don't forget, everybody, our live chat is open. And if you want to join the live chat, ask any questions for our inventors, you can do so. And I'll post the comments on the website, or actually on the live stream. So let's get to it. Who wants to start? Who wants to be the lucky first person to start?
They're saying
Anybody?
today is a special day in the solar world. Somehow there's cosmic energy that's coming from the sun that's supposed to shift us from one dimension to the other, but I don't know how true.
Yeah, there was come to mention it, day before yesterday, there was a big X flare and it hit the southern hemisphere. There's quite a bit of radio blackouts, like shortwave and stuff like that. I believe Southeast Asia was affected, Philippines was affected, all that region, South China Sea area, that was affected by the solar storm. And there was aurora going on too. So if you lived up north, you were able to see a bit of a light show going on.
Nice.
Yeah. Well, there was one back, it was what, March, April? We had that huge, outburst from the sun. There was like 2 or 3 X flares within a 24-hour period. We saw the aurora up here really, really good.
It's called CME, coronal mass
Yeah,
ejection.
right. And what does that entail?
It destroys satellites. It destroys telecommunications. It could literally,
So yeah, it's like from what I understand, it's charged particles that actually get ejected from the sun.
That happened today?
That's what day before yesterday. Yeah, day before yesterday we had X flare, but it affected the southern hemisphere, so we were kind of lucky. It happened, I think it was 2 a.m. in the morning. So yeah, I was sleeping.
Yeah, I think we were lucky. Everything, like most of the devices, were not in operation, so a lot of people might have not gotten as affected as if it was during the daytime.
Yeah, I think the communications like shortwave and radio communications for say like the Navy and stuff like that probably was affected. There was some probably radio blackouts with that. So yeah, that's probably highly possible that that's what was going on. So Nathan, what have you been up to this week?
Well, I broke my Tesla coil last week, so I dropped it.
Oh right.
And it got cut like at the bottom, just like killed the wire. So it's about this far from the bottom, right? So I just cut it out a little bit and put it on a switch. So it's now on a toggle. So now either I can use all of it or I can cut that portion out. So what that does is allow me to go from perfect resonance to not resonating and then back. So I can flip back and forth with the toggle in order to do it. It works perfect for my gravity flyer now.
Wow.
So toggle mean what? Variable resistor you're using? Like
it's a switch. It's just a switch. It gives you it goes from full power, so 2 poles and then the extra one so that you can get over to the other side.
Yeah, how about if you used a variable resistor instead of a toggle? Do you think you would be able to correct that fine tune of the resonant frequency at that part of the coil?
Well, I don't need to correct it. See, one side, when you connect it one way, it connects all the wire. So that gives you perfect resonance, right? But when I turn the switch, it gives me out of resonance. So now I get feedback in my coil. So it heats my number 1 coil, but then it shoots an energy burst as soon as I turn it back to oscillation. So I get a massive energy burst out of it, which is perfect. It was exactly what I wanted. It was the luckiest accident ever. So
really,
yeah, I was trying to figure out how to do it. You know what I mean? And it happened on accident.
What, it fell off the table or something?
Yeah, I was trying to show somebody the ultrasound box, and I was talking to them for a guest last week, and it just fell off the table. So nothing I could do about it. Just fell, and the board hit it, boom, dead on. And once you mess with that wire, it's just going to spray. So it was either rewind a whole new one or just see if you could play with it a little bit. You know what I mean? Make something out of it. And
yeah, I got a question for you on your construction. When you wind the coil, do you spray like a glue or an adhesive on it to keep the windings from separating? How do you do that?
As soon as I'm done, I spray it with a spray lacquer.
Oh, okay.
And then it sticks everything to the PVC pipe. So it'll go in between the wire. I mean, even though it's so tight, it'll still get in there and stick to the thing. So it'll stay, and then you can put another coating on it if you want.
Listen up, everybody. That's a tip when you're building Tesla coils.
Yeah, you don't have to put it on first. You don't want it sticky while you're doing it. You just want it tight as you're winding it. The tighter it is, the better. I have to wear these little tiny glasses, my wife's reading glasses, just in order to see the wire where it comes in, because you have to be like just off by an angle like this when it comes in. So it will sit in there perfect every time.
Right.
So, and with the smaller the wire it is, the harder it is. The bigger the wire, cakewalk.
Yeah.
So.
Yeah, usually I made mine, if I did make Tesla coils, would be anywhere from a 24 to a 26 gauge. That's usually the size what I used. I didn't go up to say like a 30 or 32 or a 36 gauge. That's too crazy. It's just too
I used 28 on the Gravity Flyer, and then the gold one behind me and the red one behind me are both 32.
Both 32. So yeah, you have more patience than I do.
Well, I tried 34, and it was just like fine hair. It was no good.
Yeah, and it breaks easy too, right?
That was the problem. I broke it 3 times.
Yeah, that's discouraging when you're like almost done, and the friggin' wire breaks. It's like,
And there's nothing you can do about it because you already calculated the resonance frequency before you built it and knew exactly how long it had to be.
Yeah, yeah, that's hard. Yeah, I know the feeling. I've done that a couple of times where I'm wrapping it and then it breaks.
It was a good idea with the switch, Nathan.
Yeah.
Yeah, like so,
it works.
Yeah.
You know?
I've made a few Tesla coils, and I used those little ion generators that you can pick up on Amazon for like, I think they're like less than $20, and they put out 11 kVA, not much current, but they put a high voltage out, and I was able to jump sparks about 3 to 4 inches long.
Yeah.
Like so, and it's loud too because I was using basically a spark gap to do it, so the thing's loud as all hell, right?
That's crazy. Sean just chatted in. He's researching a rectangle wire for his next Tesla coil. That'll be fun.
Yeah, Tesla did pyramid-shaped Tesla coils.
Oh, wow.
Yeah, if you watch the Energy from the Vacuum series, what Nathan's been posting, there's one where he's talking about John Serjanka. It's this
John
guy
Sedeka?
that yeah, he had some coils that were shaped like pyramids and conical, like 2 pyramids facing each other, and they join at the point out. And they were apparently coils that Tesla was working on. Never made it into the books, but this guy had it. And John Bedini, when he saw those, he's like, "Ooh, I like to make that."
Yeah, of course. Yeah, did you see the Tesla coil he was working on, Mike?
I've seen an original built Tesla coil by Tesla. It was at the observatory right on the mountain where where the Hollywood sign is. There's an observatory going up the mountain.
Okay.
Halfway up. I forget the name of the observatory. I think it's the Observatory of California. If you go in there, they have an original Tesla coil. And when I was there, they were running it.
Wow.
It was the freakiest thing I ever seen in my life. 9-foot lightning bolts coming out of this thing. It was in a Faraday cage. It was in a Faraday cage. I just caught the very end of the demonstration, but I'm just like, oh my God, I don't believe it. So after the demonstration, I went up to the window because it was behind glass because, this thing's shooting out, 4 million kilovolts, bolts of lightning coming out of the thing, right? You have to isolate that area. It was in a Faraday cage as well. I walked up and it had said original. It had a plaque on it that said originally designed by Nikola Tesla himself.
Nice. Well, I was talking about Sean's coil for our Monday show. Did you see that one?
Which one?
Sean's coil for the Monday show?
I think so.
It's in. I put it up for you to share it for the screen share.
Yeah, maybe put in the share and then we can take a quick look at it.
Yeah, that Death Star coil was amazing.
Hey Nathan, is your
I'll
mic
hit,
part
I'll
of
hit
your
play real
headphone?
quick. Oh, wrong one. There you go.
You're about to see some, Makeabee.
Do the Tesla coils ionize the air around?
Yes, they do. Of course. Oh yeah, big time.
It's round.
Nice. I like that. Cool.
Yeah, he does all kinds of different coils in there, man. I'll show you real quick if I can.
Hey, Paul from Toronto, fellow Torontonian. Welcome to the show.
That's
What's up,
cool.
Lions?
I'm waiting for those arcs to teleport a cup or something. I mean, they got to do something eventually. I mean, they're just for now. It's just a show. I mean, it's wow, that's cool. That's all. But what is it doing?
It almost looks like a cannonball with a fuse in it. You know what I mean?
We got to find a purpose for these high voltage transient arcs.
Application.
Yeah, an application for them, like a real.
Well, see, he puts sparks out of them, but it doesn't have to. They'll just put energy out if you change the DC. He's got AC going through it now.
Oh.
And he's got this little mini testicle, the coolest thing in the world.
Yeah,
Makes
this is
all kinds of cool design.
You could see the energy return.
Yeah.
It's
just
so cool.
amazing.
Maybe use them to drive a motor.
Anyway.
It's funny because I seen this video of this guy trying to visualize energy flowing through a wire by hooking up all these like multimeters and stuff. And I'm like, well, all you need to do is this.
Yeah. Throw a little high voltage in it, see what it does. It doesn't lie to you when it goes through there. That's the one thing about high voltage. It likes to tell you where it flows. You know what I mean? You get it up to about 30,000 volts, and it likes to tell you exactly where it wants to go, where, you know what I mean? Every direction. So then you put it in low voltage, you know exactly where everything is.
Right. So then you can fine tune it at that point.
That's right.
Good way of looking at it there. I like that.
If you put a TV next to it, it'll turn on
Well,
without plugging.
I could do it right at my desk right in front of me, and the TV's just fine. But if I put it around 50 to 60 hertz, TV goes completely blank. And if I bring up the EM field, if I try to hook it to something else that's a bit bigger, like a piece of metal, something like that, immediately turns everything off. So even at like 10 feet, it'll start making it change the channel on your TV. You know what I mean? It'll go from tab to tab to tab and start clicking like it's finding different hardware or something attached to your computer. Yeah.
So then what is this what could we use it for if we can't turn on things with it, without...
It's 360 degrees of radiant energy. It's
Maybe
not like a Tesla coil. Tesla coil has a dead zone on top and bottom. This thing is full 360. So if you put it in the center of your device, it's every which direction you want. So completely useful for different things. You know what I mean?
I was thinking to like make a stator coil, put on top of the coil, the Tesla coil emission, to see what kind of energy you pick up with it.
Yeah, I could.
For generating power.
The only thing
Sorry,
go ahead.
I found a little device. If you guys can help me identify what this does. It says signal booster. See this?
Yeah.
Motor says broadband drop amp. 52 to 1000 MHz,
Right.
something.
So
52
that's to boost your cell phone signal. So it's like a repeater for your cell phone. So if you live in an area like say like a valley or lowland, you hook up that to an aerial antenna really high, and it'll make your signal for your cell phone better. So that's what that is.
All right.
Cell phone booster.
I didn't know what it was. I just found it in the pile.
No, it's good. Yeah, they're handy, especially if you live in like in a rural area where the cell phone towers are quite a distance away. Yeah.
Or I think in my old house we had a lot of trees, and I think that was part of them. You know.
Also, lowland. If you're in the lowland, you know, cell phone. A lot of the cell phone towers, they don't think. You know, if you have a mountain, you should take advantage of it. That's where the cell phone towers should be at the highest point, right?
Yes.
Gerald's on. Gerald,
Hey, Gerald.
I sent you a link.
Hey, Gerald.
I sent you a link if you want to hop on. It should be in your email. We got one more spot here if you want to jump on. That's cool. Yeah. So, yeah, like it's kind of funny. Like when I was in the Philippines, that's exactly what they did. All the cell phone towers were on the peaks of mountains and high ground. So, like, I could be in the valley, and I was on a river, like literally on a raft, you know, in the South Philippines with a Rogers phone, and I got full bars. You know,
nice.
The Asians are good with the technology, you know. And they don't.
Oh, they're ahead of us, and their
they
cell
don't make
phone
many
rates
mistakes in that area.
Their cell phone rates are like so much cheaper than here. We're getting so hosed.
Right, it's true.
Oh yeah, like,
I know that
compared
I've never been to Asian countries, but in Bulgaria though, the cell phone's a lot cheaper.
Oh god, yeah. We're one of the highest paid. Canada and the U.S. are the highest for cell phone charges, right?
I pay for 6 cell phones for me and my kids, and a portable Wi-Fi router. Pay $600 a month.
Holy, you're paying $600 US a month?
Yes.
Holy wow, that's a lot.
Yeah,
that's a lot. No.
Yeah.
I just got my daughter a line. Doesn't give her a lot of data, but she's got, you know, Wi-Fi, and you know, she's got a cell phone number, and then, you know, I can text her. You know, she's only 12, but it's that's nothing, right? But 600, holy cow!
Yeah.
Mind you, you have more kids than I do.
They've got their cell phones, and then they have
I
their,
remember family plans being a lot better than that.
and then they connect the Apple Watch to their whole system. So I think like baseline's like $30-something, and then every time you add a service,
Check out Patriot Mobile.
$12-13.
Lulu, check out Patriot Mobile.
Patriot Mobile.
Yeah, like $10 a month.
Who's got the doggy?
I do.
They're really good.
Oh, is that a dog?
Okay.
I thought somebody was yelling in the background.
Yeah, I've got
Somebody
two
had a
of them.
dungeon or something.
No, I have them. There's a room next to the kitchen because they won't let me. If they hear me on the phone, they'll be jumping on. So I try to barricade them in the room while I'm doing anything.
Yeah, it's funny how much we pay. Hey, Gerald, we actually see you. That's
Hey.
like cool.
Yeah, we got the whole
I
family.
never seen how you look like.
I'm trying to get ahead.
Well, minus Bernie.
Trying to get
I'm gonna
ahead.
fix this here. How's everybody doing?
Good. What
Good.
happened?
Hey, what happened to your camera? I want to actually see you.
There we go.
There you go.
It's
Okay,
not
there we
just
go.
a head, no.
Yeah.
How are you guys?
Good.
Good. I missed the first little bit. I've been busy.
Yeah, I've been fighting the car. Got to redo the exhaust on my car. It's falling apart.
Oh,
So
yeah, I hear that. I lost a car like that once. The exhaust fell off right in front of a cop. and I had just my license just expired.
Oh, here goes that car.
Yep.
You have a lot of. You have a lot of.
Go ahead. Oh, sorry.
You have a lot of great experiences with cops. I noticed.
It was a long time ago.
In the galaxy far, far away.
25, maybe. Yeah, I've had an interesting life. I don't know what can you know what? I always looked at it like this: if you're gonna do anything, jump in with both feet, and if you don't lose your legs, then it was a good thing, right?
Yeah,
so,
exactly.
If you don't lose your legs, I just got that one. See how slow I am?
Yeah.
I used to be a lot slower.
I got a video for you guys to see. I was hopping the coil again. So this time it goes up a little higher.
Nice.
I saw that.
And no, this one's different. I haven't put this one out. I don't know if you guys want to see it or not.
Oh, put it up.
Yeah, can I?
I'm not sure if I can. I got 6 spots here. I'm not sure if I can pull up a 7th.
Well, if I present, would it work that way, or can I even present?
Well, you could do over your channel that you're on right now, but to add to my screen, I might not be able to do it because I don't have the full version.
Well, Mike, just pull me off the screen so he can present it.
Or I could go backstage and then watch from backstage if you
Yeah,
like.
yeah, go back. Yeah, just until Gerald just shows this video quick, and then we'll pop you back on.
All right. How do I do
Okay.
it?
Just back out and then log back in. Yeah, and just stay backstage. Yeah. All right, let's give it a shot here. You can
All
share
right,
your
give me
screen
one
there.
sec. I'll just set this video up.
I think you can present. It's just guests. You only have 6 guests. They can present though.
Okay, I'll have to try that. I haven't tried that. I thought I was capped at 6.
Okay, so we share screen.
6 guests, not 6 windows.
Okay. We'll see how this works. Maybe I can pull her back on in a sec here. She's just on the backstage there, so I can pull her back in anytime.
I wish I knew how to share my account on here, and so we can add more guests, but I don't even know how to do that. So.
All right, can you see that?
Okay, I'll pull it up here.
There we are.
Yeah. Awesome.
Okay, let's see if I can get it to play here.
And turn it up a little. Volume.
Yeah, maybe a little bit.
Yeah, I'm at max.
These little pieces of paper, we each have a gram. It's 12 million stack. That equals 6 grams. So,
That's how you calculate the weight.
here, with
Yeah.
oil
No, that's smart.
what we have here is just oil sitting on this thing.
What were they?
6 grams.
They're half a gram each. There's 12 of them, so there's 6 grams there.
Right.
The coil weighs 4.5.
Nice.
Holy cow.
That's cool.
So what are you doing there? Are you pulsing it with forward DC or what?
I'm just pulsing the backside of the circuit from the cap bank, but now
making like a rail gun there.
Yeah.
No, you can't make it like a rail gun though, because it's the coil topic.
Well, yeah.
Right?
If you were to stationary the coil, then you could send something through the center of the coil, like iron or whatever.
Maybe.
No, not maybe. Definitely. It's it's a solenoid operation. You can they already make these guns that are coils. That power better.
Yeah, rail guns. Yeah. The rail guns. The U.S. Yeah, the U.S. military or the U.S. Navy is actually working on some very big prototypes, and they're scary. They're super powerful.
Yeah, I don't want to make nothing like that. I'll tell you.
Hey Ben, we can hear you typing.
I think they make it to launch stuff into orbit.
Oh, here we go. Let's see. Can't get away now.
How much? That thing must have weighed a pound. No, half a pound.
And that's it. So I'll stop sharing.
How much power were you actually putting into that?
You know what? I was just using that wall plug, and it was literally one pulse, 23 volts. Bang. That's it.
That's it. Eh?
Nope. Through my circuit.
Was it rectified?
Backside of it. Okay, so it's a modified dual feed. Well, it's not so modified. Where Bedini takes the power from the diode off of the base and it goes to your secondary battery for charging, I take that and I fill a capacitor bank with it, and I use the capacitor bank to make the coil hop, and it hops with a lot of force.
You mean the anode?
You could call it that. I remember I said before, I'm only showing a pittance because there's certain things I don't want to show on YouTube that might just get it taken off.
Kill my algorithm, man.
So I'm only showing little bits and pieces so that everybody gets the idea what I'm doing and what it can do.
Very nice.
I'm just going to scoot out for a quick smoke. You guys just carry on. I'll be right
What was
back.
the cap value on the voltage? What did you pump it up to?
What's that?
What did you bring the cap value up to?
It was at 23.
23 volts.
23 volts. I showed it on the camera.
Oh, I didn't see. It's hard to see.
Yeah. The reason why it's got such force is because of the geometrical form of the coil itself. It compresses that field in such a dense spot all at once that it pushes off. But now again, that's sitting above a magnet. I haven't showed anything else.
23 volts is not a lot. Yeah.
I like the other one where you had the little stick and you showed it jump first a little bit and then it jumped off of it. That was beautiful.
Well, what I just showed you guys, picture this. Maybe I should just wait and show it to you guys during the presentation. So that hopping, let's say for instance, it's possible. I'm not saying I've done it. I'm saying, let's say it's possible that you could levitate it a little bit off the magnet and then hit that big hop, watch it jump, and then stop higher up and then hit it again. I'm just saying.
Yeah, you're just saying, huh?
That's all I'm saying. I haven't done it.
Hiding it from us. You're hiding it from us.
Possible, but we'll see, right? I guess during the presentation.
It's possible there's a Tesla coil behind me. It's the same thing.
No, that's not what I mean. No, I just think it's possible. I haven't.
You can't do it with direct current unless it's pulsed or you have frequency from AC or something.
Like quantum supercondition.
How could I have that considering that the function generator was off?
Well, you did pulse it when you made that one contact.
That's true. That's true. Yeah.
Mm-hmm. And you did disconnect right after you connected, so that completes the pulse.
But if I held it there,
then it would not be a pulse. It would not be a pulse. It'd be constant current.
So this much I could say: if I held it there, the coil would have came down so much, but it would have stopped, and it would have been way higher than you guys are used to seeing, maybe 6 to 8 inches.
Right, because you're keeping the EMF flowing through the coil constantly, so there's no reason for it to come down. It should stay up.
That could be it. Yeah.
Unless the battery dies.
A definite possibility. A definite possibility. Let's just say that.
I'd be curious while you do it. Just take a piece of tinfoil, just a thin little piece, and just see if the piece of wood lets it stick to it.
Oh, yeah.
Just see if it's got any pull to it, like a charge in it.
Well,
you want to hit it with square wave, high frequency square wave.
No, that's not what I'm getting at. I'm just wondering what his coil's putting off. So depending on what it puts off, if you put off enough, light amps on it, you might get a charge on the wood.
You know what? I tried your experiment when I reversed the polarity on the coil, and I didn't use high voltage. I only used 24 volts, and it sucked right down to the wood. And when I went to pick it up, you could feel the force.
Oh yeah,
yeah.
It definitely changes it.
Now, when it comes to doing the charging of the surface and the hopping, I don't think I'm at the right voltages yet. I need to use the circuit that Jeremiah Pop built for me. It goes from low to high voltage, and from low frequency to high frequency, you're able to change it to. It's kind of like a function generator in a way, I guess. It's a neat little circuit. So I need to try that to see if what you and I were talking about works. I'm seeing signs that it's gonna. So
yeah, I have a feeling you're right there with all the stuff that I've been seeing. By the way, did you understand what I was trying to tell you on your page? That it's not a torus with a donut around it. Like it's not a toroidal with just a hoop around it, and that's the field. It's a spiral. It keeps getting bigger, and it keeps compacting the center like you're pushing rods down in it until, you know what I mean? They get so compact that it just condenses the energy into one singularity, while the outside energy gets bigger to come into it. So
You're right.
Like a black hole?
Spiraled.
It's an
there's a
omnidirectional
sphere.
hoop. It's a three-dimensional omnidirectional.
Not quite. Nathan's got the right idea. It's a huge vortex.
It's
And then when it
omnidirectional.
comes to the center of the coil, it compresses. But because of the way that the coil is wound, it actually compresses into the form of a sphere.
Omnidirectional means donut.
spheres.
Donut. That's what omnidirectional means.
Yeah, and then there's two spheres on the inside of that, a positive and negative, and they're chasing each other. And
Right.
it
Not
pushes
two,
the energy
not
outside
two.
like a disc.
They're not two. There's two flows. Not just two lines. There's two flows, and those lines are spiraling all around in two different directions. Of course, this way too, in two different directions. Yeah, both ways, horizontal, vertical.
Yeah, I kind of see where you would see that. I know what you mean. I know what Nathan means.
Okay,
too.
so
I can
conventional
see both.
current is what we use to describe everything because it's just easier. That's the only reason.
Yeah, but this is not AC or DC, and it acts nothing like it.
No, conventional current is described in one direction, from plus to minus. But
But there's no plus and minus on this. It's a vortex, so
yes,
it's
I
a
know.
flow.
And the
It's a
electrical
flow.
community knows that too, but they don't discuss it in that way because it gets too confusing. So
It's not
conventionally,
confusing at all. It makes
No.
it more confusing when you try to put it in base terms like a Steinmetz.
Yeah, because Steinmetz, the way that he put it, he literally canceled out the ether scalar
That's
wave
right.
third component. The
Well,
component that's
it
the
only
most
makes it more
important.
confusing for troubleshooting circuits.
Yeah, but you're not troubleshooting the circuit. You're building a vortex. It's completely different.
Well,
Yeah,
building,
vortex.
troubleshooting, and understanding circuits, not just troubleshooting, building and understanding them. A lot of reasons why conventional current is described in one direction, not just one.
I understand that, but that's not what he's creating.
We should just try to learn with that one direction.
But that's not what he's creating. You can't put it in conventional terms because you just get it wrong.
Understand that the scientific and electrical community realizes what you realize.
Yeah, but that's why they've gotten nowhere. That's why they've gotten nowhere, Mike, because they don't understand this. They still see it like you do with AC and DC. They don't see it right. No, they don't see it right. I'm sorry, no. No. Baloney. This is why people don't even understand Bedini's work. They don't understand the spike. They don't understand the most important part of the circuit. They think it getting mesmerized by other garbage in it. I saw it yesterday when we were watching Ben's video. All the garbage around it, and the answer was right there in front of him. Right there.
He explains it.
Right?
But
Yeah.
nobody listens.
You know, it's hard to train people that way. It makes it harder to teach.
Yeah,
but see, that's just the point, though. If people weren't trained in the classical electrical engineering and they were trained right from the start, knowing that there's a third component that's ignored, then maybe they'd build systems in order to bring that component out, and we wouldn't have to deal with this lack and the crap that everybody keeps building. That's just my opinion.
I agree. There's a geometry thing in there that takes that vortex to another level.
They call that conventional current.
Yeah.
So for just understanding sakes, not for reality's sake, for
I get that.
understanding's sake. That's why they call it conventional current, for the understanding's sake, not the reality's sake.
I guess what we're saying is we don't care what they say. We're trying to get an understanding so we can build the system. And if we
you're right, it does flow in both directions, but conventional current flows forward.
I hope I'm not
yelling.
yelling.
We're talking about it also flows forward and backwards, because we're talking about.
No. Yeah, I think you're missing it. Some things flow on the outside, some things flow on the inside. There's more to it than just back and forth.
Yeah, I think a lot of the mainstream science, they don't take into account the heavy side component, right? I think that's what Nathan's talking about. The heavy side component is there. There's a field on the outside, and with current, it's moving, it's in motion, as well as the current going through around the wire itself. And the heavy side component is probably conventional science doesn't look at.
Yeah, but even Steinmetz acknowledged it when he looked at two wires and said the field around the wires, okay, when they're bare versus when they're shielded. So Steinmetz knew it was there, but he used the shielding to get rid of it. Okay,
right.
That's why it's important to know both, because you know what he got rid of that Tesla used. And that was the same thing, but that's the same thing that Gerard Morin was saying, is the energy was flowing on the outside, not on the inside. Just a little bit on the inside to make it follow or track with it. That's it. That's the biggest difference in it. And even Steinmetz knew it was there. And he worked to get rid of it.
And he was the last, probably, of the old school engineer that realized and knew this stuff.
Well, yeah, but guys, conventional science does recognize what you are talking about. They do not recognize it. They do recognize it, and they do explain the current on the outside of the wire very clearly in conventional science. They just do not teach with that. They teach with the flow that goes inside the coil. They don't teach with the flow that goes outside the coil. They never.
Yeah, but that's where the disconnect is.
Well,
that's where all the backyard mechanics don't get to play. That's where the inventors get stopped dead cold, because the electrical engineering society has decided that it is to be like this and spoken of like this and written like this.
Well, they teach scientifically. They teach electricity with the way we're teaching it, forward and backwards. But conventionally, for the conventional reasons, they do not. They teach it in one direction. So, but scientifically, when it's taught that the energy flows in the opposite direction on the outside of the wire. This is shown in black and white videos. Come on.
Hold on. I can tell you right now, from the math that they do and what they're quantifying, they are not calculating it. I'm sorry, they have a view like yours when they calculate, so they don't get it. I could tell you that from looking at the math. It takes 2 seconds to point it out. They absolutely do not calculate it right, because they don't know the ins and outs of it.
My system itself proves it. Everything that they try and cancel out in their electrical engineering circuits and building of anything, I literally use in my system. My system wouldn't work without it.
Everything they dump to ground is what you use.
Let me throw a picture at you guys of trying to calculate amperage with non-conventional current. You're going to see no current flow, because it's going to be going one way and the other, and it's going to cancel the flow altogether. Your meter's not going to move. So they make meters to read one direction. You see, you can't. Okay, there's another reason why for you.
Yeah, and if I was building my house, that'd be perfect advice. I'd absolutely follow it.
You can't measure.
That's not what I'm building here.
You can't measure it unless it's conventionally measured.
You can't measure this anyway. That vortex, you can't measure with any tool you have. You don't have a tool that can measure it.
I'm talking about electricity in general. You can't measure it.
Yeah, well, anybody can measure that. That's fairly simple. I could wire my whole freaking house right now, man. That's easy. That's easy compared to what we're doing.
But try to measure the AC wave going in two directions. Meter. You won't be able to.
I don't care. I just don't care. It's not something that I'm interested in. I want this extra energy. I want the dark energy. I want the spikes. I want the potential. I don't care about AC and DC. They're a means to an end for me. You have to use what you have to use in the circuit, but in the end, we want the vortex energy. That's all we're looking for.
You know what I'm finding with this vortexes? These coils don't just have, I guess pulse DC would be considered a form of AC. So they don't just have AC, they have AC and DC. It's just manipulating the fields in the right way, like what you're trying to do with the gravel flyer. It's going to make this thing hop and settle, right?
Yeah.
So, I agree. Go ahead.
You have full control over a DC pulse, where an AC, most AC generators are designed to run, in North America at 60 hertz, or if you live in Europe, it's 50 hertz.
I call it the zombie.
Yeah, it's the zombie frequencies.
Exactly.
Right?
Just straight like.
Yeah, like 60 hertz, believe it or not, is more parasitic to the human body than 50 hertz.
Yep,
50 hertz signal. Yeah. So, that's why everybody's, so disconnected, and they got all these mental issues and everything. It's all the 60 hertz that we're using. It's just screwing around with our biological system.
Didn't they used to use like 120 hertz or 130 or something like that? And then they changed
Probably.
it?
I think Tesla was probably, I think Tesla was working with it, but I think because of the current purposes, they wanted him to drop it down to a 60 hertz frequency.
But I don't think it was Tesla that did it. It was Steinmetz.
It was Steinmetz designed it like that, yeah.
Yeah, through GE, he changed it because they were much higher, and then they had like 2-pole and 3-pole, two-phase, 3-phase, you know what I mean?
Yeah.
Going on, they had to put it all together at one.
GE ran the world for the longest time,
or
at least had a good hand in it, so.
Yeah, Steinmetz was
the grid brings in like 7,000 volts into one phase and then splits it up.
Yeah.
Yeah. And that's why most factories now run on a 3-phase system, right?
7,000 volts AC.
Like we have a 44,000 volt transformer outside of my work.
4K to 7K.
Nice.
Right. So, and then it steps down. A lot of our machinery run at 480 volts. Then you got your welding, all the welding rigs in there. You're talking huge amounts of reactive current going through that building. So that's why we have a transformer outside the building, because the demand is just so huge, right?
Yeah, I guess if you're welding all the time, eh?
Oh God, yeah. And we have probably about 25, 30 welding stations.
That's straight current.
Yeah,
I believe there's another way.
What are you guys making?
Well, I can't really talk about
that many welding machines. Like, what are you making?
A time machine.
Yeah. Well, the company makes.
It sounds. Go ahead.
We're a subcontractor for NATO, so I'll let you figure it out.
Oh, so you make all kinds of stuff. That's good.
Nothing we can hear about.
Yeah.
Let's not get YouTube shadow ban for saying trigger words, but
exactly.
I get it.
We're being listened to, you guys, by multiple people, and I love it. Do you guys realize that Michael Perrone, an alien scientist, after our last live, was discussing the very tech that we were discussing, and actually agreeing that over Unity is possible? I don't know if you guys caught that.
Yeah. No, I didn't watch the show. So what did they exactly say?
Well, Michael Perrone was bringing up the fact that electromagnetic frequencies and electromagnetic systems might actually have a key, or there might be something there when it comes to over unity. And then he referenced a few systems, not ours, mind you, but he's starting to think outside the box, I think. I like Michael Perone, but he's really in the books kind of a guy, right? And hey, that's cool, but I don't know. I don't follow the rules. That's my system's based on not following the rules.
Yep.
In fact,
the thing,
Mike, what do you know about Borfine?
you know, like all of our systems that we use today are a closed circuit. Since you open it up to the outside environment, allow energy to flow into the closed system, now you've got more energy coming into the system that you're actually using to produce it. So
yes.
you're opening up an orifice into the closed circuit. And Bearden talks about this a lot too.
Yeah.
And the other technique that's very important to this component is you cannot kill the dipole. So you have to somehow harness the energy that's coming into that system in a way that it's not killing the dipole. And it took me a long time to figure out exactly what he meant by it and how to actually do it.
The open core dipole.
So in very simplistic terms, what does that mean, not killing the dipole?
Okay, well go ahead.
That is very hard.
No, go ahead, Gerald. Go ahead, Gerald.
Well, I was just going to talk about an open circuit, which could go to explaining the dipole, like an open circuit and a closed circuit. So in the system that I use, or we'll say, for instance, a battery and a light bulb, that's a closed circuit. And all it's doing is draining the power from the battery to light the light bulb.
Right.
And when there's no more power, the light bulb shuts off. So to give you a visual of what I'm doing, I'm turning the power for the light on really quick and creating
an open load situation,
like a burst of energy, so that entropy can start right away. But before entropy goes completely and drains the battery, I give it another kick, kind of like a swing on a pendulum, right?
Right.
The pendulum.
As long as you have,
do that.
As long as you have, as long as you, I think the point what he was getting at is non-equilibrium. As soon as you have equilibrium, that's when things die off. When you keep the unequilibrium, the system can regenerate itself.
Everything's looking for balance.
Right, because nature's going to kick in and try to equalize the system.
Yeah, because equilibrium means entropy. Equilibrium means a balance of both sides, right? That's when the battery and the bulb doesn't work. So
if you have a system with power that's enormous on one side and it's really small on the other side, the system is going, or the nature's going to kick in and try to equalize that by giving it a kick of extra energy. And most of the time, we just ignore that extra energy.
So another good example of what Gerald was talking about, the closed circuit. So you have battery running a light. Okay, so let's change the circuit a little bit. Okay, so one part, say the positive coming off the light, say we put a very large coil there. And instead of using just regular straight DC current, let's start pulsing it now. So now you've opened up the circuit to a back EMF. The back EMF collapse emanates around outside of that closed circuit. So that coil is the
outside
orifice.
the open core.
That's right.
Not the closed core, which is a round ring toroid core. That's a closed loop core. Bedini doesn't use that kind of core. He uses a straight open core.
Can we visualize? Can we visualize back EMF as like a reverberance of the signal itself, or an interaction between something else?
Well, how is the back EMF going to go around a ring core?
You can. I think it's called a resonant frequency, like a resonant frequency, like a second frequency.
Well, yeah. When you get your coil into a resonant frequency, that's when it's at its optimal operation.
Resonant frequencies, two frequencies with a pulse.
Right. And
it's got to have that pulse in it. It's like an amplification of those frequencies.
And meanwhile,
exactly what I'm using.
Yeah. So even just running power through a wire, that wire is now going to create a magnetic field. So if it's running straight DC, you cannot harness any power from outside the system. As soon as you start pulsing it through a coil, now you're creating a massive field, and now the field is interacting with free space where energy exists, and it collapses. Now you're going to draw or open up that orifice of energy into the closed circuit system now.
Now
So
imagine that collapse with a toroid core. Imagine that
So it
collapse
acts
with
like
a
a
toroidal
vacuum.
core. It's not the same thing.
It doesn't matter what kind of
How does it collapse back onto the toroidal core? It doesn't. It goes to the center of the toroid, not back into.
That's where 0 point is.
Yeah, because the wave function collapses very sharply.
Different thing happening here.
So if you're
A
using
toroid.
AC,
It depends if you have an open core or a closed core, because it'll make a difference. Gerald has an open one, Bedini has a closed one, because he fills his core with rods, where Gerald has an open area.
Yeah, open.
So two different effects completely when you do it.
Yeah.
All right, Gerald, you gonna school us?
I don't know about that. I'm trying to draw it really fast, and it's not going to work.
Well, anyway, the flux in the core and the toroidal core has a hard way of escaping, whereas it's a bar core. It has two open
Well,
ends.
it's closed.
It's
It's
two
a
open
closed
ends on that
circuit.
bar core, and the flux can escape as well as enter.
When you have a toroidal core, it's closed.
It's closed,
So the
right? So
field
how is
can
your flux going to escape, or anything on the outside get in?
I'm not talking about a toroidal core. I'm talking a regular run-of-the-mill coil around.
Right.
I'm not talking about a
That's what an
closed.
open circuit is. A bar core. A closed circuit is a round core. When you're talking about the
Toroidal.
EMF of the core.
Yeah, I wasn't talking about that. I'm talking about an open core.
I know you were, but we were also talking about closed circuits, so I wanted to explain that.
I'm drawing this totally backwards. Here, let me see if I can do this.
So that's why I think Bedini went with the open core, open circuit.
Of course, because that was the way he was getting the radiant energy spike into the system.
Right, and I don't think he would have gotten the radiant would get into a ring core, is what I'm saying. Because there's no open ends.
It has to be an open core. Has to be.
I think ring cores are good if you want a strong spin power, and hold on to it.
Give me a sec.
Got a lot of typing to do there, Ben?
You said what?
Sounds like.
Got a lot of typing to do there?
Yeah,
It's
I'm
like Charlie
talking to
Brown.
Sean.
Sounds like he's got an old school typewriter over there. You just got to pull the little lever and pull it back.
That's right, with the ding.
He's a fast typer, though.
Hold on. Sometimes
ding.
Sometimes it defaults. Yeah, my bad. It defaulted to my webcam audio mic. So let me change that.
Let's say this is the wire. I don't know if you can see that.
Right.
The glare is probably.
Well, you can see it. Go ahead.
Okay, yeah.
Okay, so when you pulse power through, it goes through the center, but it goes this
Can
way.
you enlarge
Right?
his screen?
Yep.
Enlarge his screen.
Yep.
But then there's also energy that goes on the outside of the wire, and it goes in a circle. I know I'm going to screw this up here. Hopefully I can get this right. But your power goes around the wire in one direction, and it goes through the wire in the other direction, and there's your current. So when you pulse a bunch of power through, you're not getting all your back EMF in your line. You're canceling out so much of it, right? So your current can flow through better than it would as if you were going straight DC. Because if you're going straight DC, you get all this current that goes around the wire, slowing down the current that goes through the wire. And that's why you get that heating up.
It builds
Does
up.
that make sense?
You know, you're right. It builds up.
That makes a lot of sense. Thank you, Gerald.
Perfect sense.
Okay. So now with my coil, Mike's talking about how a toroid, it's a closed circuit, but my coil doesn't work like that. It works like a series of line inductors, and it pushes the energy out around it like a spiral, like Nathan was talking about. But then it comes, that spiral comes into a fine point. This is the fine point. But because you have a north and a south pole.
I was talking about iron core, not the core of a coil, an iron
Okay,
core.
fair enough. But I thought you were talking about a toroid. My point was you got a north and a south here. And when that vortex comes in, I know I'm messing this up, guys, and it focuses right here in the center.
On the blotch wall.
Right?
Blotch
And
wall.
Exactly. And then you'll have another one that comes down out of the bottom. But in the center of the coil, you'll have your north and you'll have your south chasing each other because your vortex from the bottom is south in the opposite direction of the one coming up top. But they meet in the middle from that compression, that energy density, and then they chase each other. That's what pushes the energy out.
Right.
So
when they spin, and they're spinning gyroscopically.
Yes, they're also spinning like this.
And that coil is
That's right.
coreless. It's a coreless coil.
Yes.
Yeah.
Do you think you can?
Coreless, not core. Coreless.
Do you think you can
no iron.
like be able to have control to maneuver this thing up or sideways, or just by
Absolutely.
the energy?
Actually, the video I just showed you guys, I didn't bring it up, but I wanted to see if anybody else would pick it up. Not too many people did. Well, actually, I don't think any of you did. When the coil hopped and pushed that aluminum can up and shot forward, there's a reason why it did. If you watch the way I put the coil on the magnet, I off-centered it just a little so that that magnetic field would push it out the back like a squeeze. And when it went to hop, it hit the aluminum cap, flipped it, and shot it out forward. It's kind of
there
part
is a
of
way to, like
Gerald,
to control
you could use
it.
that same mechanism to relay.
So I'm done presenting, just so you're aware.
Gerald, you could use that same effect to make a relay.
Just kidding. What's that, Mike?
I said that same effect that you just described, you could use it to make a relay.
Yeah, and let's say you got a coil here, right?
Oh,
you got a bunch of pickup coils on the outside. Let's say, for instance, this sucker can float. Well, these are electromagnets, and they're all the way around, right?
Each one's
so in
electromagnet.
theory, well, listen, the coil here, if it was floating, right, and these are attached to the coil, in theory, because they're electromagnets or scalar magnets, or call it whatever you want, when you pull more power into this one, it squeezes the back end of this field and it pushes the coil this way. From my experience. And
So
if I
you
put
could have maneuverability like very easily just by controlling which
from 12
electromagnet
separate
you want to.
from 12
Yeah,
separate
that's
points
interesting.
around the coil. Yeah.
But they're not in series.
So now I'm done presenting.
Are they in series?
Yeah, they're very important for propulsion.
Yeah.
No, they're not in series.
They could.
Yeah, but
they
your-
were. You wouldn't be able to do that.
They could be though.
Your burst of energy comes to the center of that core, though. So when you want to go super fast, you have to take advantage of those funnels in order to get it. So you have to bring the energy higher through the funnel in order to get it to go in one direction faster. So
yes,
you go side to side with the other ones, but the other one has to be going that way because it's like what was Schauberger when you put it in there, you're sucking yourself through the vortex.
Yeah, that Schauberger device is something
Yes.
else, man.
Yes, and what you could do though is reduce your pressure from being pushed up and add the pressure from behind like a pinch, so you'd be going at an angle. or you would turn your power down to the point where you're just about to fall, and then you would push power into the back end and shoot forward.
Now check this out. The B-2 bomber uses the ability to put the static on the outside, giving it easier access to go fast through the air. You know what I'm saying? So you're actually eliminating a lot of inertia because of your vortex in the center. That's why they move that way. Because that's the exact reason. We already have the technology. It just needs to be amplified with the vortex. So they don't have that in that bomber.
Okay, so from my very near recent research, I believe that AC has to be on the outside for the skin, and it's DC on the inside column. Know what I mean?
You gotta have more like a potential than an AC, I think. It's got to interact with the environment.
Yeah.
And the environment's going to give it more energy, because when you get up in the atmosphere, you get energy. So you're just like running a Corona motor at that point. So you need that static to blend with it. You know what I mean?
Yeah. For every 3 feet, it's 100 volts of potential. I think that's how it works. Every meter, it's 100 volts of potential. So, yeah, and if you can collect that static while you're up there, you stay up forever.
That's exactly what Otis T. Carr was saying with the X1. That's the machine he was talking about where he got over unity. It wasn't on the ground that he got over unity. It's when he got up in the atmosphere he got over unity. That was the kicker right there.
Yeah.
That's very interesting, Nathan.
Just set that sucker to float and just zap the energy off of it all day long.
Yep. Because all he's doing is creating a spike like Bedini right into a capacitor that goes into his Tesla coil in the center. This isn't difficult. He's oscillating it in the center in that Tesla coil, and then the Tesla coil itself puts a longitudinal wave out. So if you had a hollow Tesla coil in one of these UFOs, you would get the same thing. You'd be able to create the vortex easily, because it's not unlike when you spin a UFO in the shape that it is. It's just like the Tesla turbine blade. It'll bring it up and in and then down back in.
Right.
So you're going to be able to take care of the energy that way. So if you could think about it that way, I run the Gravity Flyer without a shell, but if I put a shell on it, it completely changed everything. See, but mine's 2 toroidals, not 1. So your coil's 1. I got 2, which makes it more like a magnetosphere and a balanced, and it makes it more of a field generator than it is a machine like yours.
Yeah, I get what you see. I get what you mean by that totally.
Coming in clear, Nathan.
Huh.
Strange, isn't it?
Now I see why you gotta hit it in order for those 2 fields to come together, and once they do, you're gonna get that hot.
Because
I see that. Yeah.
Remember your bubbles? You had the 2 bubbles, right? And you made 1 bubble, then you made your second bubble, and your coil's above it, right? Now I need to squeeze it in between the 2, just like you did, and pop it. It's like pushing down on a balloon and then letting it off.
I just got to find what pressure I need. That's all in this balloon.
Yeah.
That's all it is.
Yeah, we're like working on the same thing, but they're a bit different. Like if you put your coil in the center and then I put a plate spinning around it just with an open hole in the center, I can get a field to generate like everywhere around this thing. I can get you your field on the outside, and I can get you a big field on the, even further than that. I can get them to interact for you. I can get you everything that you want with that coil, in the center, perfectly. So we can go to outer space to whatever you want. We got like a force field around it. Tell you, these people that work on this thing have no idea how this field works. It's a specialty field, man. It's like I got stuck with a field generator that actually just lifts occasionally. You know what I mean?
So once you've created that bubble, have you tried the radio thing yet? The radio experiment?
No, I haven't.
Yeah.
I got to pick up an old radio.
I'll tell you, somebody suggested something to me the other day that was kind of eye-opening and possible, but not sure about yet. When you're creating a bubble and it's you can pick it up in the static of an AM radio, you're creating a field. but a forced field, a field that can't be penetrated by electromagnetic signals whatsoever. So you're essentially creating a force field.
Yeah.
Now, it ain't going to stop bullets, but there's no signal going to get inside. Cell phones don't work with my coils on. I can't run tests in the house when, you know, people are walking around because I'll kill their phone.
Nice.
Yeah. So yeah, it's
turn it on when it's Thanksgiving time and the in-laws get a little crazy.
Oh, yeah. Then they don't have any
nice.
phones anymore.
Oh, yeah. You killed their phone. Yeah.
That's like Wi-Fi. I have to. I can't do tests in the house anymore because I've killed 3 Wi-Fi boxes, and they keep replacing them, right? And they're like, I don't know why these things are blowing, but
you're killing people's internet now. That's not funny, man.
Hey, Joe, I blew out one of my hearing aids the other day with my ultrasound. It just exploded in my ear.
Ouch.
Yeah. So I had to bring it in and get it replaced. Then how did it break? I have no idea.
Yeah.
No clue. It just stopped working.
What else do you say, right?
That thing's dangerous.
Everything's dangerous when you got free energy sitting around you everywhere. God, you know what?
Yeah, the space is saturated.
If you hook up your table like this one right here behind me,
pressure
it's all metal. Hook it up to something like that, to the gravity flyer. Say goodnight to every electronics in the room.
I think
it just starts shattering them, and then you'll feel the field coming out and busting everything as it goes, and you'll start having to replace everything.
You're creating pressure waves inside your garage.
Yeah, and
it's a condensed area. Yeah, so like that's what I say. If I put a shell around this thing, it would completely change how it works. That's what I'm doing in my garage. It's the shell. My garage is the shell right now, so it has to be outside.
Oh, you think that's what it is?
Except for when your shell grows exponentially huge, like almost.
How does glass react?
See, but you don't have a Tesla coil field holding it in.
I don't need it.
That's the whole reason to put the fields on it like I do, is the Tesla coil holds in all that energy that would normally go out to the rest of your room. Yeah. It'll hold it in a bubble, and it won't let it go. You have to apply the field the right way, but it'll hold it in. I do it with high voltage all the time.
I see what I'm getting the bubble, but my bubble's like
your field's just going everywhere. It's creating a bunch of static. What I'm saying is, if you put a Tesla coil on it, it'll suck that bubble right back together. I'll talk to you about it later, but it has to do with how mine works versus how yours works, and combining them would change the whole experiment.
I want to do that.
This kind of sparks a memory. John Hutchison, back in the 80s, he had several Van de Graaff generators. He had Tesla coils. He had a whole bunch of stuff going on at the same time. He got it into, I guess, creating that bubble that you guys are referring to.
Yep.
He actually made one of his laboratories disappear. It vanished.
You said laboratory?
You know what he doesn't
the
talk
entire
about
building
much?
disappeared.
He did the ant
Why
thing.
You know what he doesn't talk about much? Why
Where
he
did
had
it go?
He shrunk his laboratory. It didn't disappear. He shrunk it.
Hold on, guys. What, Gerald? What do you say?
He doesn't talk about this at all. I don't even know if he'll bring it up. He's brought it up before, but the reason why he had to get out of New Westminster in British Columbia was because when he was doing tests in his apartment, things were lifting in other people's apartments.
Yes. Yeah, I know.
Yeah.
Floating.
Yeah. That's amazing.
Yeah.
That's
when he sent his
he did
when he told me that
the whole building and he was done.
Yeah.
They threw him out.
Yeah. When he told me that story personally in 2005.
Yep.
When he sent his videos to the government, they sent them back. I think I told you guys this, and they said, "Do you realize, like, if you pause it at certain frames, your items are just completely disappearing and then reappearing?"
Yes. Yeah. It is basically the Philadelphia experiment that he recreated.
Where do you think, like, as you guys, where do you think this stuff goes? Like, into an invisible spectrum, or
I have no
where?
idea.
Nobody knows.
Like,
changes the frequency.
Bob
It goes
Lazard
into counter space.
Bob Lazard says because stars can have so much gravity that they can bend light around them. That's what happens.
Yeah,
They go invisible. They don't go anywhere. They go.
That's not changing the gravity in it. It's changing the frequency.
Yeah.
Well, whatever the stump or whatever that disappeared, probably its gravity properties changed and then
So
it
is
started
it
bending
getting
light around itself.
disintegrated?
No,
So
it
is
started
it
bending
still
light
there?
around itself, like the star bends light around
It's
through
like
the gravity of the
phasing in and
starlight.
out.
Same thing happening to
So
the.
is it still there?
It's
Is it
probably still there, but the light's going around it, so you're not seeing it.
It's more
It's
than
going
that.
into it's going into counter space.
I
Whatever.
think
mean,
it's
So
that's
let's
one
say if
theory.
I
I don't
have,
know.
okay, so if I have a stick and he's doing his experiment, and I poke it with a stick, am I gonna feel something or not really? Like, you know?
No, it's gone. It's gone.
It's gone.
It's gone.
Okay, so then
it's
light's not
changed.
bending it.
So think about this.
Oh, hold on though.
Molecules
If
in,
you create
say,
a gravity
piece of wood-
field to bend light, I'm sure it's doing more than just bending the light. It's bending time also.
Yeah, it's changing the
So
time.
from there
of
you
the
can
energy in that system.
extrapolate what happened to the cup.
So the theory is, if you change the energy of the
It's in a
molecules,
different time.
whatever it is
It's still there, but
that
in a different time.
then when those molecules' energies change, you change the time differential on that, and it literally shifts into a different timeline.
Yeah,
you can't see it, you can't feel it because it ain't there. It's in a different
The
time.
cup's still in the same place, it's just there in 1950, not 2024. It's in the same cup, same table, but in 1950, or different table, or whatever.
My
same
God,
space,
do you
but-
understand? Okay, do you understand the significance of this? It means we can
Gravity
actually
field.
send messages back to the past, or we can
Yeah,
send
with
things
gravity
to the
fields.
future.
I don't know about that.
Technically,
Come
you
on, why
can with
not?
gravity fields.
Because it would take another exact same system in that timeline for you to communicate with in order for you to have that link.
That's for
You can't just
bidirectional
go from
communication,
hole.
not one way.
The time
You
machine
can't-
paradox. You
That's
can
for
only travel back in
communication
time
back
as
and
far
forth,
as you
not
made the
one way.
machine.
You could do one way and get a message back.
So Nathan can
guys-
have one of my coils, and in 10 years from now, as I'm running the coil here, if this was to work, this is in theory, he can turn on the coil and talk to me 10 years in the past from the future because he has that identical coil, and he changes all the energy in his molecules to match the energy of the molecules of where I'm at in my time. So we're able to talk. Does that make sense?
That's quantum entanglement there.
Yeah, I guess you could call it that.
So yeah,
I think you're pulling a Stargate out of phase.
Right.
Maybe.
Where they're just in a kind of a different area, the same area, but you can't interact with them.
But then how does that explain the fact that if you can't interact with them, wouldn't you be able to feel the same mass in the same space?
No.
Well, maybe there's a space that nobody can interact with. None of the dimensions. It's just it's an intermediary space, like in the Flash. You know the Flash.
I
how
love
he goes
time
to
paradox.
Well, like
Skinwalker Ranch.
The Flash
They're
goes
in a
to
different
one place
phase.
that only he can go to because he's got light speed. It's called the light force or whatever.
Wouldn't it be determinant that the actual location has to be the same though? You can't change like
That's
different
my
locations.
thought process. The location stays
It
the
has to
same,
be.
but the energy changes, and therefore the time on that changes. Could be wrong. Yep.
Well, we have to think about that for a minute. This is heavy stuff, man.
Yes.
The people and things in it, though, change.
Okay, but now my thought.
Faster or slower or whatever.
It would be like if I came to you out of phase and I walked over to your tube TV, I can interact with it because of the energy, and I can write you a message on your tube TV.
Right, because that tube TV has more than one phase. It has more than one phase, I think. No.
Hey guys, sorry to jump in
radiating.
here.
Inductive reactance,
Sorry to jump.
capacitive reactance, all kinds of radiations. You know.
Sorry to jump in here. I have Thomas waiting in backstage. I'd like to get him on here to get talk with him for a few minutes. Can one of you jump off and just stay backstage, and then we can pull you guys on after?
I'll step
Mike,
up
you'll
if you
step
want.
out. Whoever, it doesn't matter.
I'll step out. Oh,
Mike stepped out, Lulu. You're already in.
Oh, okay. All right. I'm going to add Thomas. Hey, Thomas. Welcome to the show.
Hello, hello.
Hello.
I actually jumped over here more to listen to it because I'm getting better quality over here than off of YouTube.
Oh, really?
Yeah.
Just we haven't spoken before. Welcome to the show. Can you tell us a little bit about yourself and what stuff you're working on?
I don't know the about myself stuff, but I'm working on what I'd call replicator level 3D printer upgrades. Like one of the more recent ones that I have done the experimental stage work on is using a 405 nanometer laser at 500 milliwatts. I can basically take rust and reduce it back to iron without any kind of oxygen removal process, leaving the raw iron deposited on whatever surface it's laying on.
Interesting.
The intent is to basically go both directions, though. Be able to ablate things and then whisk them away, and using electrostatic energy and the speed that it's moving, the weight and the ratio and all, and charging with different frequencies of lasers to take whatever comes off of the ablation and separate it out, so that way it can then be reused to print something else out of it. So
you're doing something like nano scale manipulation of matter.
I'll have to look into that. A lot of it though is based on instead of like grabbing the material and putting it where you want it, you flood the area, but you don't give it enough energy to bond except where you want it to bond, so it's then attracted to where you want it to go. That way you don't have to know where it's at, because it was one of the first things I heard people complaining about was you can't really know where an atom's at because it's always in motion. It's like, why would you need to know? You know where you're with photons, you know exactly where you're putting them, and you know by the frequency what they're going to do whenever they hit whatever it is. And something a lot of people, I guess, don't get is that when you get a reflection, the frequency of light that reflects is actually stealing energy from that part when it bounces off it. So it does the inverse of absorbing the energy from another frequency. That way you can take two overlapping and basically nullify each other. So
So how would you cancel out that reflection?
Well, that's the thing. I don't want to do that. I want to use that like a donut of reflective frequency around a dot of absorptive, so that way the center of the donut, whatever size you make that, is all that's getting charged. Everything else is being decharged. That way you can get down to a single atom sized deposition without having to have frequencies of UV that will basically destroy, or X-ray that will basically destroy whatever they're hitting. So
So are you just doing this basically in your garage, so to speak, or are you doing this at a university or?
No, it is backyard stuff. So in fact, I've got a whole. I got lucky and turned a quarter of a Bitcoin into 6 Bitcoin, and before I spent a bunch of it trying to help somebody maintain their place while they were on a medical leave. I went and bought a bunch of equipment to get ready for it. So I went from like the amount of stuff that I need versus the amount of stuff I need versus the amount of stuff I have to, much closer. So I still have some more stuff, but most of it I'm going to build myself, like using nanopore or mesopore line alumina that's been lined with like carbon nanotube material to grow my own laser diodes that are, I can hit any frequency pretty much I want. I just have to have a system to vacuum it all out, so that way those higher frequencies will not be absorbed by the gas that's in between it and the surface. So
have you experienced any transmutation of elements?
No. No, I figure that's probably something that needs to be, somebody needs to work on that when I get the Replicator 1.0 and I start mass producing those and sending them out to people. People can figure that out then, and that way we don't have to worry about, do you have enough of this or do you have enough of that? But in the meantime, you're still going to have like a pretty decent period where basically we'll go from those who have these will no longer be resting on a fiat-based capitalism and go to an actual physical-based capitalism that can't be manipulated. So, you know, you need some gold and you got a whole bunch of carbon you processed, you can trade that versus the, you know, more rare gold to print something out that you need to print. But when we can do something like what you're talking about, which this type of equipment would be the thing that you'd be able to, if it's possible, that would be how you'd be able to build that equipment to get precise control. So that you could take a whole bunch of hydrogen or a single hydrogen and like a mercury atom and, you know, combine them together to get whatever you want, splitting others apart and neutralizing them too. So that way, basically they're not unstable and, you know, continually degrade, releasing radiation and falling apart. Like the way they were discovering that the sprites off of lightning bolts neutralize radiation in the atmosphere.
Yeah.
So you basically build
shoulders
one thing
charged
from another
clusters.
thing. So you're building like whatever atom you want from other atoms without releasing its harmful effects. You're just building, you know, from starting from something small to something bigger, something bigger. Oh.
Right. Yeah. Take whatever's common. That way, basically, you don't have to worry about whether you have enough material of the right type on hand. The whole point of this thing is a childhood dream. Thanks to Star Trek, because that was the first thing I saw, was that if you don't have this technology, you can't really do deep space flight, because when you get busy going somewhere, you can't just pull over halfway to Alpha Centauri to run to Walmart because something broke.
Right.
Right. You need a manufacturing center or a process somehow.
Yeah.
Right. So
they have a 3D printer on the ISS right now. So if they need like a plastic wrench or whatever, they could print it there and use it. You know, so they have experimented with 3D printers in space. So
right. Well, and
yeah,
that's the thing too, is I've used the same laser technology to take titanium dioxide white powder and break it down to turn it back into that brownish black material that forms from crystallized titanium dioxide. So an electrostatic field on it to attract the oxygen off it, since the titanium has way more weight than the oxygen, will allow printing solid titanium. So that means you can just take rust and titanium dioxide and mix it and get an iron titanium alloy that you can print with like anywhere from 500 milliwatts to 2.5 watts worth of laser power.
So you can actually produce some pretty exotic metal alloys with this.
Right. So,
And
or
use
not just exotic metal alloys, but you can get wetting between substances that normally you don't see happening, where like they'd have to revert to using, or you know, to basically they'd have to start with something like indium to get it to wet on, say, glass, to get a metal surface that you can then bond on the indium, which then you're relying on the strength of the indium, which is not very strong. But if you can bond titanium metal straight to glass, you have a much better material when it comes to you know, abrasion resistance and flaking and whatnot. It's not going to happen. So I mean, there's a lot of different things with the electrostatic fields. You could probably grow quasi crystals any way you want to. You just have to keep shifting the frequency to whatever you're wanting. I typed something in earlier that apparently didn't show up because YouTube is still censoring me. High voltage.
Yeah, I wonder why.
Well, yeah, I was gonna say high voltage. You notice, like, if you have high enough voltage, you can send hundreds of watts of power across a tiny little line and get almost no losses.
Yeah.
And I was thinking about that, and I was always of the mindset that basically supercooling materials means that it's like the equivalent of taking what is that? It's not Rosenberg. What's the cradle? Is it Newton's cradle? The balls on the strings. They're all
yes.
Okay.
Right.
Imagine if you take those and you have them disjointed, so instead of them running in line, they're running more like this, and you drop one on the end. How much of that energy will make it to the other end, and how much will be excreted out of the sides from them trying to go sideways? a lot of that energy is going to come off to the side. It's not going to make it to the other end. And that's what a lot of our atoms are doing whenever you're trying to shove electricity through a wire. Higher voltage, though, if you've got a coating on it, that coating is a dielectric. They call it an insulator, but it is a dielectric, and it absorbs electron field energy, which means that if you have high voltage, you now have a high static pressure charge. It's squeezing those atoms to keep them from moving around anyway, but allowing that electron to shoot straight through. So it may be possible just to wrap a wire with an insulator and then a conductor and an insulator and a conductor and then 2 insulators on the outside, just apply a really high voltage to it, like Mylar, a millimeter thick layer that can handle up to 440,000 volts before it allows discharge through it. Then you can run 12 volts through it, and it should come through just as easily, even across a long distance on a little tiny wire. You should still be able to get all that power out the other end without losing hardly any of it.
Wow, that Newton's cradle is a brilliant analogy.
Right, instead of cooling it down to get it to stop wiggling around, just put pressure on it to freeze it in place, like we do with a pump. But we're using an electrostatic pump instead of using. So
hold on. Can you take the stuff that you're breaking down and use it like a paste between layers, and then hit it with static electricity charge and get it to form together or sandwich together and stay there? So like you'd be creating 3 different layers, and it would stay as a solid layer once the material hardens in the center.
You might be able to. I don't know. All the stuff I'm working on is working when it comes to manufacturing is working on layers where you just build the layers up. But to keep it clean, an electrostatic field is being placed on it while there's a laser running through the area, so that way any air that tries to get in will get buffeted away by the electrostatic charge. So you only have like maybe a 1/4 millimeter distance between the print head and what you're printing on, but you're keeping all that gas from getting in there, so you've got a pure, like, complete vacuum in between the two. So
Nice.
Interesting.
That way you don't get any contamination. So if you're building those layers up, you can just build that middle layer that you're wanting, and then you drop the material on the next layer above it, and just bond it right to it. You're excreting the whatever the contaminant is that allows the material to be worked with. That's being pulled back up through the build plate or through the electrostatic plate to separate it from the rest of the area. So.
That's interesting. I wonder if electromagnetic confinement would help you at all. It's like you said, compressing, right? I don't know. Just a thought.
Yeah. I don't know. I mean, the important thing is like on the conductivity is just keeping them not only from moving around, but also keeping them all in the same alignment, right? On what you were talking about earlier, by the way, that whole temporal thing, something that I've worked on a bit before, and actually to get to that point where you can even do spatial displacement, you have to figure out what that frequency is that the entire universe is oscillating at. And it's somewhere in that static field that we consider noise, but it's going to be really hard to detect. Like we're going to have to go through and detect all the other things and separate them out. And when we find that frequency that you just can't detect it, it's probably somewhere within one of those frequencies.
Is that
then you have to contain?
Is that what Floyd Sweet's vacuum toroid amplifier was doing when it was tuning into the ether? It was
I don't
tuned
know.
to
This
the
is all
frequency
stuff
of the
I've just
ether.
thought of on my own. I don't know who any of these other people are. So
Do you think it's
this is all stuff that most of it comes from dreams. Like I pretty sure what Tesla was doing, and no one got a chance to see it. You're familiar with an electroscope? What it is?
Yep.
Okay. Put a separate plate inside there, a third plate to go with those foils. That has the wire, instead of running to your input, it's running to a ground, so that when the foils expand, one of them will touch that ground out, releasing that power, causing them to collapse back down. So you get a pulse of power running through it, and then it starts expanding again as the voltage builds, and it pops again. This keeps the voltage level that's up in the atmosphere from being at ground zero by it constantly being touching to ground. Because if you put an antenna up in the air and you ground it out on the ground, your zero level is going to go across the surface of the Earth and then up over where that antenna is at and then back down. It's not going to gain any voltage from being up there. But if that's disconnected so that it has to fill that foil up to make that ground, that allows that voltage to go up in that area and then collapse. With the pulsing, what he was doing in a dream that I had, it was causing that voltage to draw power out of the atmosphere from it pulsing up and down in voltage. So, well, I mean, what I saw was he had 2 electroscopes set up, and he had on his transformers he had 3 coils. There were 2 primaries and 1 secondary, and the 2 primaries wrapped in inverse. So that way, basically, when it went out of the first electroscope and through the coil and dumped into the second electroscope, it would then return back through the secondary coil going the opposite direction before it went to final ground. So you got a positive and a negative shift on the AC wave that it was generating from that static field. And then you just do whatever he wanted with it from that point, and then he could transmit that information. That you know, the energy. I mean, that is information, even if it's not you know, intelligible information. If it's just a general constant like wave, kind of like the carrier wave of FM waves, you know. So and then you can just capture it anywhere.
Well, I can confirm the antenna power situation, because with my coil, if I run a line up a pole and put a toroid, aluminum toroid at the top, and I take the end of the secondary and I ground it, my primary becomes a pickup coil, and the voltages I get are insane. I'm actually just about to do an experiment on video for that. I have an old barn that has to be torn down and a pole that goes up 30 feet. And I'm going to run line between the barn and the pole, insulated from both. And then I'm going to tap it in the center and run it through my coil like an antenna, like what you're talking about. So because there's a primary and a secondary, my secondary will act as the antenna, at least the input of the secondary, and the output of the secondary will go to ground, and then my primary becomes like a step down transformer. At least that's the idea.
Are you building your coil system the way the Wardenclyffe Tower plans were designed, with the 2 primaries? Because there's like 3 coils in that, and one of them is like a step stage where it's more like having like 1.5 coils. So you got the primary coil that's having an effect on the secondary coil, and then that gets pumped into that long coil that comes off it. Whereas the other ones were like they were kind of like the successor to the Pelletron. So they were just meant to be a voltage step-up mechanism that you could then dump directly onto that, instead of using some other generic form of like electrostatic generation from a mechanical process. Instead, you could use that to charge your electron buckets in a Pelletron to do whatever it is that they were wanting to do, whether it was like, you know, atomic acceleration or whatever. So
I'm using geometrical formed open core electromagnetic coils. So they collect energy. It's like 1,500 feet of copper. It's 750 feet wound one way, and then 750 feet wound 180 degrees out of phase. So it allows me to collect more energy than at least it seems more energy than I'm putting in. But my third coil for what you were referencing is part of the pickup coil system I have on the outside. So there's 12 coils on the outside that are 120 wraps each. They're ferrite cores, and I pick up energy from those. So that's.
Are you presenting your thing tomorrow?
I'm trying to. I'm almost done. I'm so close. I'm because I had to add something to it. I had another breakthrough, so I had to add something else to the paper, and that's why I wasn't ready for tonight. Otherwise, I'd be doing a presentation now. But yeah.
My God, man, leave something for the history books.
Yeah.
Sorry.
No, you're good. I'm just really excited to see your presentation.
Yeah, well, I'm hoping to get this experiment into this presentation, but we'll see, because the place I have to do it at is an hour and a half out of town.
Well,
it's the same place to do the experiment.
I'll tell you this: do the experiment another time. Let's just get what you have now, and
Well,
because we've been waiting 2 months.
Yeah, that's
You guys are
not my
working with
fault.
you guys are working with all that high voltage. Have you used any of this to make your own electrodes?
I might actually inadvertently be making an electric right now because my coil, when I put it in epoxy resin, had no bubbles. But after resonating it and doing experiments with it, I have multiple spheres inside this thing that look like they're coming from the wire.
That's what I've been asking. Everyone that I have talked to that's made electrodes has used heat to get the atoms in whatever the material it is to be more fluid, so the electrostatic field can then alter the way they're formed to form the negative and positive triboelectric charge on the surface. But no one has used something that's in a more solvent-like state. I mean, that's still a chemical reaction going on, but it should still work. If that works, then it should still work with like xylene and styrofoam dissolved in it as a paint, and then put that field on it while the xylene is evaporating from it, which is a really good material to work with something like that because it dries so slow. It leaves a glass smooth surface on both sides of whatever it is you've dissolved in it. So in fact, they use it as a slower so that whenever you're spraying something and you want it to be glossy, it's got more xylene. The stuff that's matte finished has less xylene because that allows it to dry faster, so it comes out rougher.
Right.
So the smoother the surface, that means that your negative or positive triboelectric field is going to be lined up perfectly along the surface of that smooth surface to be able to control its shape. So
interesting.
I just wondered about that because you're talking about collection, and if you have a positively charged electrostatic field from all the atoms sticking out of that side that are buffering up against the thing that you're pulling all that electron field energy from the atmosphere, it'll have a stronger draw.
Yep.
You could literally draw down below the zero voltage field in the atmosphere at that point.
Yeah.
Before it pops.
Yeah. My coil does get, I guess you could say zero field. My coil gets really cold if I'm pulling large loads out of it, and the loads are resistive loads.
That's very interesting. That's the thing that I'm working on for my energy source for all this equipment is based on triboelectric inverse materials with a small gap between them and a coating of a neutral material like graphene or I call it leadphene, basically a sheet of a single atomic layer of lead, something that basically has that 4 electron field, so that it can receive or give up electrons. That way it won't interfere with that triboelectric effect that's underneath it.
Yeah.
So that when the air bouncing back and forth between the two of them, when it hits the positive one, it's going to give away its electrons to it. When it hits the negative one, it's going to pick up electrons off it and then back again. That way it builds up a field, and that conductor will pull that energy off of it.
So it's like a dielectric. It's like a dielectric capacitor, right? An electric.
Almost, except that you've got free ranging gas moving back and forth in it. So as long as it's still warm, it's generating power. The more power you pull from this thing, though, the colder it will get, because you're literally converting thermal energy into electric energy, not allowing thermal energy to move through it, but rather you're just literally nullifying the thermal energy because it's being stored away as an electrical potential. So
yeah, it's going to be a big discovery when they finally figure it out, because apparently you can't turn thermal heat, electricity or energy.
You're touching on the entropy thing. This is reversing entropy.
Yeah, well, I use entropy. It's part of the system. I use
That's the whole point of the black hole. The black hole is the entropy, ultimate entropy system that basically breaks matter back down, and that's where all this dark matter, the effect that they consider dark matter is coming from. It's deactivated matter. As soon as it gets activated again, it'll recombine into hydrogen again, and we start all over again.
I had mentioned this with Nathan on a live a few days ago when I was running my system at, I think it was 24 volts or 28, I can't remember. I just decided to see what would happen, and I took my lighter and I put it in the center of the open core, and my voltage changed on my pickup coils. So, and that's just
throwing
a
that plasma in between there.
What's
plasma, throwing that plasma in there between the gap with the flame. That flame is nothing more than plasma.
Yeah. Yeah.
So.
But you shouldn't be able to pick that up, though, no?
Well,
because
atoms shouldn't be able to quantum entangle either. But you know, if you take a magnet wheel with a bunch of magnets stuck to it on a really good bearing set, and you put another magnet wheel on the other side of the room, also on a good bearing set, and you start spinning one of them, the other one will spin, even though there's no physical connection between the two of them, just because they're magnetically connected. There's the reason why you get these weird, like spooky action at a distance, because they're less affected. They've got a better bearing system than any metal bearing you can put together, or any other type of bearing that we can build in that magnet wheel, because they're literally free floating in space.
Yep.
Just whizzing around, interlocking with each other. So
zero resistance.
Yep. So as close to it as you can get. I mean, you're going to have the resistance from the effect of each other and their fields, but we're talking field interference, not physical, like grinding interference. So that's
coils don't heat up at all. I can make them heat up. I know how, but when I'm running them, they don't. Heat's not an issue. In fact, my issue is I'm blowing horizontal deflection transistors that are good for 1600 volts because I'm creating too much. So yeah, working on some things. It's interesting where I'm getting.
So you need higher voltage transistors?
Yeah. I may not need transistors at all in the near future.
I was gonna say you might, if I get when I get done with the testing, if I get some positive results, I'll shoot you some info on how to make your own transistors using Starlight. That might help. So
that'd be cool.
You guys know what Starlight is?
You talking about the material Starlight?
Yeah.
Yeah, I have a good idea if I'm right.
So think this way: remove whatever ideas you had of how it was made before, and instead use your activator, because they use baking soda in the generic ones.
Yeah.
Change that to something else as your activator, so that you have two different batches of material. That one whenever it forms, has a positive dopant, the other one has a negative dopant. Paint the two on top of each other, heat them up so they exfoliate, turning back into that pure carbon, which is a semiconductor, but with those dopants in it. Like one side has phosphorus in it, the other side has boron in it. You now have
I never
diode.
thought of that.
Well, this is the thing though. That's a form of carbon-based aerogel. So imagine how good that is at thermal resistance while being very good at conducting electricity. And that's what makes a good Peltier. A good Peltier is a diode junction that thermal energy will not travel easily through, but the electricity can freely flow through.
That could have some profound implications if put into the right system. That's interesting.
Could be a secret to making much more efficient and easy to make at home-based solar cells too. That instead of them getting hotter, they actually get colder while the sun's hitting them.
Interesting.
The more power you allow them to generate, as long as you close the circuit, pull the power off, they start pumping that heat out and evacuating into the atmosphere, getting colder.
Definitely interested in that data. Yeah. One thing I haven't tried, I'd like to try, is put my coil in front of a solar panel at night, just to see if it picks up energy. I don't know if it would. Because it's photons, right, that we're dealing with when you're talking about solar panels. And when it comes to this coil system.
Well, hold on. This is my theory on that, though. Photons in a vacuum, the actual physical particle, is just the speed. The reason it moves at the speed that it's moving at is because that's the speed it requires for electrons to be evaporated from whatever they're in. So there's not an ultimate speed for it. That just happens to be the speed that it happens at, and we don't have a way of accelerating beyond that. Just like there's a speed that you require to escape the body of liquid, the bonding that goes on beyond between the hydrogen and oxygen in water that you have to accelerate until you reach that point in order to create steam. And
That's
that
an
point
interesting way of looking at it.
So I mean, if that's true, you could prove it by basically using your own electron emissions directly instead of using light. You're hitting it with electrons. The important thing is
I
the amount
want
of
to try it right now. No?
Yeah, you just need the right amount of potential so that way you don't overcharge the solar cell, because that's why some light doesn't work, because it overcharges it, so it causes a bridging action where the energy, the solar cell just short circuits itself. I found that just putting a piece of Lexan polycarbonate in front of a solar cell actually increases your wattage. I tested the amperage coming off it and the voltage. The voltage will drop a little bit, but the amperage comes up high enough, it makes up more than the losses in voltage. And that wasn't even the reason I was doing that. I was just wanted to see if, since UV doesn't do any good at generating power in a solar cell, I wanted to see if I could block that since it turns into heat. And maybe it's even affecting the solar cell the way UV affects a photo. You leave it sitting out in the sun, what happens? It eventually
it gets
fades.
all yellow and
It fades, right? So if you can interfere with that destructive measure while letting the rest of the light through, your solar cell should last a lot longer.
That's interesting.
But it looks like it may actually be by blocking out the unnecessary frequencies of light, you stop them from counteracting the energy that's created by the necessary frequencies. So I haven't had a chance to do it yet, but at some point, you guys have seen polarizers where you use a quarter wave and half wave rectifier.
Yeah.
That way you can get, instead of it just turning black and clear, it actually creates color effect.
Yeah.
That system can actually hit a single nanometer of light. You can actually tune that so that you can actually pick a nanometer, a specific nanometer frequency of light, and that's the only one that's coming through at like 97%, while only about 3% of all the other frequencies are getting through.
That could come in handy.
Yeah.
That's
so you can build a great big one of those things and put it in front of, like, a mirror, and then have that go down through like a lens to go on to
it's like a filter. It's a filter.
Right.
You're filtering the solar.
Right. I thought about using that with water, because I'm sure there's probably 2 frequencies of light that water reacts to, and everything else is basically just noise. It interferes with it. So if you can get those 2 frequencies hitting that container of water that you're electrolyzing, it'll reduce the amount of power of electricity you actually need to put into it to break the water apart, because it's already charged by those 2 frequencies.
Right.
So,
and you structure water like sunlight. UV actually structures water. Right. So
we have a viewer in chat asking, do you have any videos or anything that you can show us?
I think the only thing I've got right now is one of those color polarizer units. I did a couple of those where I basically was just rotating them around, but they're on a different YouTube channel. Let me see here.
Thomas, you've been on APEC
anything
before,
you can pull up would be great. If
Yeah,
not, we'll save it for another stream.
That's where I remember meeting you. Yeah, you were on APEC a few times.
Let's see.
So let's not all talk at once.
Sorry, I didn't mean to kill the mood or anything.
No, you didn't. You did. Check this out. You guys seen this book before?
Oh, this is actually one that I've got that's probably useful too. You guys are talking about magnets, and you were talking about epoxy. I crushed some neodymium magnets, peeled all the chrome off it, right? Just put it on a steel anvil, and then took a hammer and just tapped it to break it up into powder. Mixed the powder into epoxy, and then in a Ziploc bag, and then I laid that Ziploc bag on a magnet. And I actually ended up with a magnet that had a magnetic field only on one side.
Oh, really?
Huh.
Wow.
My guess is because when you look at it from the side, you can see it's solid black material on one side, but as you get closer to the other side, it turns into these thorns or spikes coming off it, the way like ferrofluid forms. So my guess is because it's oriented properly, that the magnetic field is coming out the sides until you get to the very tip of that. and that's creating magnetic destruction on that side. Like you could put it any direction at all on something, and it would flip over to the other side. If you had it on the side that had that no magnetic field, it would keep flipping over to try to stick to the other side on a piece of steel. And you know, I mean, the whole point was to try to find a way to take all these magnets that are the wrong shape and make them the right shape. They're not very strong though, so we need to come up with a way to basically create that electrical connection that happens in the crystal structure whenever it's formed, to have, you know, an amplification of like the magnetic field, or I should say an amplification of the magnetic field collapse, because that's the other thing I found. I thought magnet, the higher the end, the longer the reach would be for the magnets, but it's actually not.
So you have to complement the field geometry to the crystal.
Right. So
well, you got me thinking here, and this is a question for everybody. So if I was to say take a long iron rod and heat it to the point of like almost liquid, or for that matter, pour a new rod and have my coil surrounding it, and I was to pulse it, if you were to get the domains going all one direction, that creates a magnet, correct? And just a magnet?
I don't think it'll create the domains going the same direction. I think what you're going to get, like you see whenever metal cools, is instead of it being disorganized, you're going to see the domains constantly flipping back and forth, but the ends will be facing either toward one end or the other, and that's where your magnetic field, I know, comes from with iron. Like a neodymium magnet is not made of neodymium; it's made of iron, and then it's doped with neodymium and boron, and it's two neodymium and one boron to every 14 iron atoms, which coincidentally form a very specific iron crystalline shape. So what you're getting is a reflector in the middle and two magnetic lenses on the ends in those paramagnetic material of the neodymium, so that it can basically take all that energy that's coming from those 14 atoms that are linked up like that and concentrate it coming out of both ends, instead of it just being, you know, willy-nilly, so it ends up interfering with the other crystals adjacent to them. So I've still been trying to get some people to try the same thing. At some point I'll probably have to do it myself, of just like I don't know if you're familiar with soldering with other materials other than, you know, just your tin, lead, and antimony and whatnot, but bismuth, you can use bismuth just like regular tin. You just throw down the rosin core flux on it, and then heat the surface up and drop the bismuth down on there, and it'll melt and bond right to the steel.
Really?
So that's kind of the thing, is to build a stack where I've got 14 times the amount of material that's in the bismuth layer of iron on either side of it, and then cap it off on both ends with aluminum foil that doesn't have any coating on the aluminum, or take coat the surface by friction spin welding, where you just take a rod of aluminum and press down on it while it's spinning fast, and just paint it with aluminum metal, because it'll bond right to the surface as soon as it knocks the oxygen from between the iron and the aluminum. Honda was the one that patented that, because they were trying to weld like aluminum rods to their steel cases for their motors, and that was the best weld they could come up with, was just taking the rod, spin it up fast, and push it down on it while holding it still, and then turn it off and unchuck and let the aluminum rod go, and it would be bonded right to it.
Wow, I'll have to remember that.
Yeah, that's crazy.
So I don't know what all metals it will work like that. It's kind of like cold welding, where like if you have no oxygen on something and you take two pieces of metal and touch them, they bond right together, but you're forcing the oxygen away instead of using a vacuum. So it means you're going to have some waste, but hey, I mean, it's a lot less waste than you know, going the other route. So trying to use some sort of like mechanical and like gas arc welding and stuff like that, with all the sputter and whatnot. This doesn't even heat the material up and distort it either. In fact, that's what they're using to put all their rockets together. The casings, they roll it up so the edges are up against there, and then they take a rough like an auger and run through there, and it just grinds the material up as it's moving down through there, so that it meshes together to form one solid piece. So there's only the heat of the friction is what's generated by it. So that way there's no crystal deformation or anything like that. That way when it gets hot or cold, it doesn't cause it to pop and break and fall apart.
That's how they make perfect welds.
Yeah, Tory doesn't want anybody to know because that's like a big secret for their rocket making, but that's basically all it is. I mean, Honda already spilt the beans on it. They just never tell anybody they're using that same technology.
Wow. We have people in my chat like screaming, you need to write a book.
All this stuff has already been done, though. I mean, that's the thing with my 3D manufacturing upgrades. They're already being used somewhere in the industry on like a industrial level. That's why I have the confidence I have that bringing them together will work as well as it will, because they're already being used elsewhere and extremely effectively. So it's just nobody's taking the time to put the piece together, and you got a lot of lack of crosstalk whenever it comes to industry scientists, because they got to keep their trade secrets, you know.
Yep.
So,
NDAs.
Right. Well, and this is the thing. What I'm planning on putting out is going to break the back of the corporate structure, because you won't need a big, 50,000 square foot facility to print out a cell phone. You'll be able to do it on a desktop and use an old pieces of old broken cell phones to feed the machine to make them.
Nice.
So
yeah, you got a lot of fans over here, man.
Oh my god, this is like
Speaking
really cool.
of printers, Nathan, I'm gonna get that printer you told me about for $100, and I'm gonna call you on that. Get you to give me a hand running it.
Absolutely.
If you want some really tough parts, look up Tallman 230. There's no printer on the market that uses filament that can't use this stuff. It's right around the temperature range of ABS, but it's nylon and polycarbonate. There's I don't know if they have something else in it or if it's a specific type of nylon, but it melts at like 230 degrees. So it'll melt just as easily as PLA or ABS, but the stuff is incredibly tough. I replaced parts in a Shark vacuum that had broken on the rollers.
Oh, yeah. I know exactly what you're talking about. I
broke one. I mean, they broke one from, cat and dog hair and all the other stuff. That
the little round things with the little square on the end.
Yeah, I printed one of those up, popped it in there, and outlasted the other one.
Wow, I'm surprised.
I made another one, put it on the other end. As far as I know, it was still working whenever I left there, and that was like 5 years of use, and it broke. The first one broke in like a year and a half.
I gotta get into 3D printing.
That Tallman 230, and I mean, I make stuff every now and then, even just using a 3D printer pen. So, if you can get the hot ends, you can get the really good stuff because it's got quite a bit more stiffness to it. The Tallman 910, it's almost as stiff as polycarbonate, but it's also got the unbreakability that the nylon has from them blending the two together. So I don't know if anyone else is using the blend or not, but
not yet.
Mike, I think Mike wants to come on. Let me step out because he might want to.
I can step out.
He's got a lot. No.
Put me in the background so I can listen, but.
No, Mike wants to talk to you, so I think I should step out, and then Mike should step back in.
Should I be worried? I want to talk to you outside.
No. Right,
Mike's fun.
All right.
So have you guys ever heard of the book Order Out of Chaos?
No.
Yeah.
I have.
Yeah. Man's New Dialogue.
I've heard of it.
I just got it. It's an old book. Well, older. It's on, there's quite a few parts on gravity in here. So I'm going to read it and get back to you. It was recommended through Jeremy Reese.
Yeah.
Yeah. Thought I'd bring it up as we were waiting for Mike. So
say my uncle had some strange thoughts on gravity. He for an anti-gravity rocket propulsion system and generator, he was saying that a rod of mica, copper caps for the field generation, and then drop 2 rings on it that you could charge negative and positive, creates a propulsion. I experimented with the sheet design for the gravity field generator, which is a mica and copper, but as an antenna. on walkie-talkies, and we were able to get some insane distances off of like one of those sets of the realistic like Radio Shack with the little yellow button,
right? Yep.
Gray walkie-talkie and 9-volt battery.
Yep.
We had a constant communication. It was actually clearer than across the street whenever a friend of mine went over vacation from Tulsa, Oklahoma to Cincinnati, Ohio.
Wow.
So I don't know if that's because we were using another type of energy source, or if it was just because I accidentally made a fractal array antenna because we were making the copper part, etching it by just painting this stuff on by hand as teenagers. So they were not that great looking.
Might have been both.
Might be.
Right.
So
interesting.
Something to play around with. I mean, I'm not even sure what type of minerals are even in the mica that you buy. It was just those windows for furnaces that we were using. So
yeah, who knows what it's in.
Well, they say mica capacitors are probably some of the best. I don't even know if they even make mica capacitors anymore.
They do. They're the ceramic, no?
Yeah.
No, ceramic's different.
Film.
Well, some of them are some of the ceramic capacitors have mica in between the two conductive plates. So it just depends on what you're getting. I'd always heard that like, you know, people talk about glass and Teflon and all this other stuff. I didn't realize that there's more than one component to your dielectric constant. So you've got like not only the resistance to barrier breaking, but you also have that just comes from the ordering of the material, but also you can generate a barrier resistance by absorption, which is what they found with the what is it, the CCTO? It's copper calcium titanate. So like your dielectric constant on like the high end of the spectrum with like Teflon, like a 7. But then this stuff has got a dielectric constant that goes way off that scale at like anywhere from 100 to 250,000.
Yeah, so, Jeremiah Pop was talking about that recently.
Yeah. In fact, that's where I first heard about it, and I had to go do a lot of digging and research. I've got most of the materials. I still have to make some copper oxide for the mix to make the ceramic clay to fire some up. But I told him I was going to make some because we were going to see if we could make some asymmetric capacitors, so some spherical ones. So hopefully we can use a better wetting method, so we don't have to use indium for you know, the conductor to bond to that ceramic material when it's done. So
indium's a little pricey.
Yeah. Well, it's not as durable though either. I mean, there's better materials when it comes to, you know, the other traits that they have besides the wetting aspect. So if we can get those other things to wet to it, like getting copper to bond directly to it, or using silver, or even better, use thorium doped silver. You know.
Yeah, if you can get your hands on it.
Mike, if you want to put your diagram up there, we can.
Yeah. You know what? Before you do that, I hate to say this, but I have to bail. I got the stink eye. Some things I gotta do before tomorrow.
We're gonna be signing off soon. We're just gonna show Mike's circuit there, and then we'll call it a night.
All right. Well, it was good talking to you, Thomas. Hopefully, you'll come back on again. I'm sure we can have some deep.
Actually, I'd like to get your. You got a YouTube channel?
I do. It's WPG Enlighten 4 Truth 2. These guys will give me the link.
Yeah.
I don't remember it. It's kind of a weird name, but it is what it is. Yeah.
I will say the other channel that I was going to pull that from is Morph Trust, and nobody gets that either. So
yeah,
it's meant to be like Morph, like Amorpheus. And Trust, because I'd set it up separately as like a trusted secret.
But what you really want to do is you want to go as fast
what was
as
it, the email account, and then I ended up making the YouTube channel off of that.
Simple fact, you want to put a lot of this radiant energy.
All right, well, it was good talking to you. Get the link off of them. My email's on my channel, and it was good talking to you guys all. Thanks for bringing me on, Mike.
Yeah. Thanks, Gerald.
Thanks, Gerald. Have a good night.
You're in the background there, so we'll talk to you guys all real soon.
Hey, before you go to anything else, the guy running this show, the Faraday Research, have you you were doing some stuff with ultrasonic, right?
Yes.
For
Yeah,
energy
the
injection?
piezo transducer.
Okay,
Yeah,
have you
the
tried
transducers.
taking anything like aluminum metal and dropping it in a non-oxidizing organic solvent and hitting it with the ultrasonic to break that that aluminum down into like nanoparticles?
I've never tried that.
I the last time I had a chance to try that, I got one of those little 3-liter units, the 40
Right.
what is it 40 kilohertz they run at or something like that. It's not like super
Right.
high frequency, but
Just yeah,
still
yeah, the ultrasonic
but
cleaners.
the stuff turns blue as the aluminum is breaking down in it. So my thought was,
So
it's
what
got a
is
lot
it?
more explosive power. So if you can make it deoxidize like that, you could add it to things that like you need more punch, more oxidizing punch, like rocket fuel and whatnot. It'd probably make a much more powerful rocket fuel. But the stuff you're working on, I don't know what all you could do with that. I mean, that'd be.
Oh, you just gave me a really, really, really good idea. I'm making crystal power cells, like quantum magnetics, and he uses certain materials in it, and there's a lot of oxides that create the reaction to make electricity. That might be something interesting that I might want to try.
Yeah, I saw a
So
long time ago
experiment.
somebody was making crystal cells and
So you use
the power would
ultrasonic
drop
cleaner.
way down, but then they just keep making power for years afterwards. And I
Yeah,
was looking
that's
at what he was
right.
doing.
A
I'm like,
lot of-
you were using this guy was using like water glass as part of it. And I don't know if
Yeah, I'm
you
using
realize this, but the power you generate will actually extract the sodium from it, leaving quartz crystal material behind, which is piezoelectric.
that's right, and that's what I have in my cell.
So now any vibration is
So
generating power. Even just sitting there, the thermal energy in it
Yep.
making the little atoms jiggle around are generating electricity off of that.
Yep, that's
So
that's exactly what it's doing. Yep, like the
so I
cell I
guess
just made. Yeah, here actually I have one running right now. I'll show you. And I'm predicting that this cell here should last 5 to 6 years. Let me change my camera here.
does it swell as time goes on?
Yeah.
Okay.
I use a special material in there when the crystal it can expand. I use silicon carbide, and what will happen when it starts extracting energy, it'll expand up to 300 times.
Oh
So
God.
I use a
Well,
special.
that's why your cell's going to stop working. Eventually, it's going to break that glass. We got to
Well,
figure out a way to
I'm
basically limit the amount of swelling so it gets exactly the right amount, but not go beyond it, and then it'll
Yeah.
probably last forever. There won't
Yeah.
be a
Well, I'm
lifespan.
not. Well, there's no glass, no physical glass in it. So hold on, let me.
Did
Mike,
you
can
use
you turn
water
off the
glass
screen
doing it?
share real quick? We can't see your.
Oh yeah.
Can you turn that off?
Oh right.
There you go.
Yeah. Okay. Sorry. Okay. So here's the light I have running right now,
Right.
and I got 4 cells. They're all running in series. All right.
That's good. I noticed that some of those crystal cells, if you tried to run them in series, you didn't get any more voltage out of them. Being able to get that extra voltage is definitely a major over.
Well, I can right now. Each cell's putting out about 1.6 volts, and each cell's putting out well over 500 milliamps.
That is strange why the
So-
voltage doesn't go up in series. That's not normal.
Yeah, there's something very, very anomalous
More
happening.
like it's more like a current cell, not so much a voltage cell.
Right.
Well, the most power that I actually got out of the cell was about 2.18 volts at about 1.5 amps.
It's multiplying the current with the series link, not the voltage.
And no, the voltage is multiplying. If you put them in series, I can get as much voltage as I want.
Oh, I thought you said it
I
wasn't.
just keep. No, it does.
Well, no, I was the one who was saying that was a major hurdle to overcome because a lot of other people I saw doing that, they couldn't get that to work. That like the voltage coming out of one would actually nullify the voltage on the next one or something.
Right. So I got
Typically,
2 plates.
They add typically when you put them in series.
So I'm not going to say exactly what I have in the middle, but I have two graphite plates side by side. One is altered slightly to create a differential of resistance between the from the other plate. So the anode is going to have a slight increase in resistance than the cathode. All right. I use a polyethylene glycol dry. It's basically a dry cell. There's and then after that, I have a jelly substance that I put in there, and I mix a whole bunch of elements in that jelly. And one of them is silica. So when silica gets charged, it expands up to 300 times. So if you don't have that jelly substance in there, it could actually destroy the cell. It'll actually crack the graphite.
Right, right.
So when it does expand, it expands in the jelly. So
well, what kind of graphite are you using? Are you using like a graph foil, like the flexible stuff, or are you using solid block graphite cut in flat plates?
Yeah, I'm using, well, these ones here, I'm using a graphite ingot, so it's rock hard. Okay.
Oh, wow.
Now the new cell, these ones are small. They're only about 1.5 inches wide by 3 inches long. My new one is 12 by 12 inches. So we were able to, we did a test, just a simple galvanic test with basically magnesium, salt water on a rag, and then have the two graphite plates together. We were getting 1.7 volts at about 17 amps.
Wow.
So you make gains on the square inches of space. So the bigger the cell in size, the higher current you're going to get. So these cells here, they're putting about 1.5 to 2 amps. The 12-inch cell, I'm expecting a lot more. So
very impressive
interesting
work.
Cell. So I got the I'm actually the new graphite. I replaced it with pure graphite, and it's going to be laminated on an acrylic sheet. And I'm going to have two of them, two 12-inch plates, and then I built my mix on the inside. So we're getting some pretty interesting. I had one of my test cells ran for almost 4 months, no problem. And where you think it would die off, it just keeps pumping. The energy's coming from somewhere. And still, I really, honestly don't.
My guess is it's not a chemical reaction. You're getting an electron exchange because of the imbalance you've got that's coming from that thermal vibration. The only way you're going to stop that power is to drop that to absolute zero. If there's any thermal energy around, it's going to generate more power.
Right. So if I put my hand on those cells, just the heat from my hand, the power goes up.
Yep. There you go. Just don't overheat it.
No, just the heat of my hand, a couple degrees, hotter than what it is. The power goes up, it climbs.
That's cool. It's like a supercharged solar panel.
Kind of, but it doesn't actually need physical light to work.
Right.
I think what's happening is there's quantum tunneling happening between the two plates, where there really isn't a galvanic action happening at all. Somehow the electrons or the ions are traveling from plate to plate by means of a quantum force involved. That's why they call it quantum tunneling. It finds its way.
That's exactly what a viewer just chatted in. Should have almost no galvanic action. So he's spot on that. Spot on.
Well,
Elijah.
I'm wondering if you can nullify the oxidizing potential that you see.
I've already figured it out.
In oxidized cells using citric acid or something else like that. That's or not citric, but the ascorbic acid. Something that's an oxygen scavenger, but it's not powerful enough to stop the oxidizing from happening. It just undoes it every time it happens.
Well,
or just build a vacuum chamber for every cell you make.
Well, no, there's two substances that I found out will actually greatly retard the oxidation process. So instead of my cell lasting, if it didn't have any protection, it lasts maybe 2 years. Well, now I can probably double it now.
Nice.
I might lose some of the I might lose some of the current, but if each cell's putting out say half an amp, and I got 18 cells in series, well, guess what? I got a lot of amperage behind it now, and the voltage to boot.
Let's
So
say
now I can pulse.
adding that to the lithium-based cells that I made to figure out how they're making rechargeable cells. Took the cells before I added that. If you fully discharge them, it ruins them. You can fully discharge them and it doesn't ruin them. You can still charge them right back up.
See,
I don't know how much
charge...
extra life it gives it, but if it does, I mean.
One thing I do know with these cells, if you do put an exterior charge on it, you will destroy it.
Right.
So as soon as you make it, it's on and it has no off switch.
Right.
That's it. It's on. So these ones here, these should last 4 to 6 years. Because I found the element that protects and slows down the oxidation process of one of the elements that I use in my device. Yeah, it's out there. The information's out there. I took this idea from a guy named Michael Kantz. He ran a YouTube channel called Quantum Magnetics, and he made silicate carbide power cells. He was working on it for probably 30 years. Unfortunately, he passed away in 2022. He actually had a provisional patent on that cell. I can't find the patent. It's gone. I don't think it went through. So what information that he actually did provide on that cell, I've been decrypting what he's been saying and actually trying to back engineer what he has done.
A lot of stuff don't get through nowadays.
Yeah.
Well, there's stuff that is getting through too. You've got people that are getting patents for over unity devices now, and it used to be that anything that claimed to be over unity or a perpetual motion immediately was kicked to the side, and then you'd have to go through a long court battle.
It don't matter if you patent it or not; it's not going to get through.
So
patented or open source, nobody's going to get it.
Well, this is why I said a lot of these people who are trying to push these things through, I think honestly the smarter way, if you really want to make it make a difference, use it to give yourself an advantage on some business that you're running. You know, I have a thermal diode system.
It's going to make a difference if it's as simple as putting a square in a square hole.
Okay, well, and that's what the thermal diode is. The thermal diode basically pulls heat out of a chamber and pumps it out into the open atmosphere, and it literally is nothing more than getting the distance between thermal blankets the right distance and facing all of them with the metallized side facing the same direction that you want the heat to move, because you get I don't know if you realize this,
polarizing the heat.
I didn't realize why it was working the way it was until I found this out recently, like within the last 5 years. The air around you, if you're at sea level, is still 99.9% vacuum. Only 1/1000th of the volume around you is actually some sort of solid gas particle moving around, and it's moving around at, surprise, surprise, the average speed is the speed of sound. That's why sound travels the speed it does, right? So that means that you've got a lot of vacuum between those two, that the only way for the energy to travel from one side to the other without a gas particle picking up heat and then touching something and discharging it is to turn into infrared radiation. A Mylar blanket is a dual layer material that one side absorbs 100% of the IR and it reflects 100% of the IR, which means that once it travels out of that, if it's trying to come back as IR, it just keeps getting kicked back to the other side until eventually it radiates out the other side. I took a $400 a month electric bill from the AC during the summer by just covering 6 windows and dropped it to $100 a month. I did some testing on the window with just 4 layers of this material up there with a little bit of air gap in between each layer. And the backside of that material was at 65 degrees and nothing in the house could drop below 67 degrees from the air conditioner. This was inside of a box that the bottom half was open. The sun was coming straight in and hitting the curtain that was behind it, that it was encapsulated inside the windowsill. And that heat was rising. It was still sucking that heat out so fast it was keeping that window at 65 degrees. I mean, that's one of those things that like people are gonna be like, oh, there's no way that it can be as great as that, because if something sounds like it too good, then it to be true, then it probably is, right?
Tungsten
So
will transmit better. It'll transmit electricity better the hotter it gets.
yeah. I'm not sure about the tungsten metal. I'm pretty sure tungsten carbide will, though, because
maybe that's
semiconductors,
the one.
a lot
Yeah,
of them,
tungsten carbide.
yeah, the semiconductors, the hotter they get, the better the current they carry.
The one
which
in
is
the
why LEDs,
those
you have to
light bulbs that
restrain them
are
or
made
they
out of
burn up.
tungsten.
Right. Well, yeah. When it hits black body radiation levels, probably it's not the tungsten is carrying the power more easily. It's the fact that you're generating plasma around it if there's any argon in there.
You think so?
And that plasma is going to be more conductive than any metal. So
yeah.
So
right. So maybe the tungsten has something to do with creating the plasma.
Right. Well, I was gonna say there's a duality there. Like I said, metals usually, the more power you push through them, the hotter they get, the more resistance they build. Whereas semiconductors, which are crystals, the more power you shove through them, the easier the power flows through. Which, if you have too much voltage on it, will allow so much current to jam through there, it'll burn the semiconductor crystal up. So you have to protect it from itself.
So if I'm putting, say, the heat from my hand on my cell and actually increases the voltage, I guess the heat differential is actually assisting the ionic flow from anode to cathode.
That could be part of it, other than it converting the heat from your hand into electricity.
Right. It's actually absorbing it and actually making it into a heat power source.
Right.
That's interesting.
That's the test. You need to build one that can handle pumping out a ton of energy, like you can siphon that energy from it, and then test it to see if it gets colder from the more power you draw from it. If it starts getting colder, then that means you are converting thermal energy directly. You're reversing entropy to turn it into an ordered energy source from a disordered or chaotic energy source.
So would that be a violation of the second law of thermodynamics?
I'm trying to remember which one that is. That's not the one where basically you can't get more energy out of something than you put into it, right?
Right.
Okay. Yeah, no, that stops you from violating that, because it's turning the energy that you're putting into it that normally is not expected to be able to be turned into energy, electrical energy, but you found a way to turn that energy into a power source. That's the same thing with magnets. If you get a magnet cold enough, it'll eventually stop exhibiting a magnetic field because there's no electron flow. It's literally an electromagnet, but thermal energy is being turned into an electrical flow charge through the crystal that creates a magnetic field. So the magnetic field is not coming from nowhere.
Well, wait.
So
that's
basically
saying that large bodies that are sub-zero have no magnetic field.
They're absolute zero, not a few degrees above or a fraction of a degree, but like actually absolute zero. That's the thing. If you drop to absolute zero, though, you're not going to be able to detect the thing anymore, because it won't interact with anything around it without the right amount and form of energy injected into it to re-energize it back from that dark matter state back into active matter state.
We don't have any instruments that actually could pick something like that up.
But yet the large body that is hypothetically at sub-zero or absolute, it does exist even though we can't detect it.
Right. That's why I've been saying, like the black hole thing. If you look at it, you got all this thermal energy coming off it.
So such a body can exist without heat?
Well, you're compressing everything to where it's excreting the heat from it before it gets dropped into that core. When it hits that core, it's now at absolute zero, so it can't interact with the gravitational field of the black hole, and it will just drift out without affecting anything around it. And we're not seeing any of this because we can't detect it. But when it gets re-energized, those particles will, those particles will eventually get, those particles are less than electrons. It'll recombine into the electrons and protons necessary to make hydrogen all over again.
Would something absolute zero actually suck in available energy? Because it's not moving, it would attract. It would.
No, you're looking at something that won't interact with the things around it for the most part. So that's why I said I don't know. Obviously, it can't be a 100%. There has to be something that can energize them, because we got matter that's popping up all the time, like in the Kashmir effect. So that material is probably dark matter that has gotten the right amount of the energy has been able to make contact with it. Maybe most of it just passes through because it's not moving, and something has to hit it directly to get absorbed so that it can then reactivate it with enough energy. But
Thomas, with my crystal battery cell, when I dead short it with an amp meter, the amps don't lose; they stay high. It's not losing the current; it stays up. It doesn't.
What about
move.
the voltage, though?
The voltage will go down a little bit, about half, but the current increases.
Okay. Yeah, so it's reacting like it's supposed to. Then it's following all those laws, but I still think probably the majority of your energy you're pulling from it, if it's lasting that long, is that thermal energy. It's not the material it's made out of breaking down. It's literally converting that thermal vibration energy into electrical current by swapping electrons around. It's probably because it's partially acting like a very, very sensitive diode. So
one way diode. Yeah, one direction diode. Yeah.
Have you looked into the laser ablating for making graphene foam out of things like paper and Captain Tape and whatnot?
Right. Yeah. Yeah, I've seen that.
I was gonna say, if you look, you'll see there's some where they're saying like when they go back over with a lower power,
right,
it actually causes the material to start forming into these spikes, which they eventually they stop forming because they run out of carbon to work with. But you could probably add more, carbon to the atmosphere with like some well, I don't know if you'd want to use propane, but like maybe vaporized wax or something like that. Even carbon dioxide should still work though, because it'll deoxidize if you're using a UV laser instead of the blue laser they're using to deposit on that. So you could grow short nanotube structures off of your graphene foam, your carbon foam structure that you're wanting for one of those sides. That might increase your at least your amperage versus the amount of thickness of the material. Like increase the energy density is what I'm looking at.
Yeah, like the current is there. Like I'm getting well over 1 amp with each cell. So I got 4 cells, I got 4 amps. So say I put a light on it that requires 300 milliamps at 12 volts. It's running that light at 300 milliamps. It will only draw what it needs to run that light. Now, if I dead short it, the amps go through the roof.
Right.
So.
Yeah, the nanotube structure just basically is like taking the material that you're working with and crumpling it up so it'll act like a much bigger surface area cell. So
it seems like it's pumping. So when you draw current on it, it expands, right?
Right.
And when the expansion happens, that happens in the jelly substance in the cell, so that prevents it from fracturing. And then when the current is released off it, or the load, then it contracts back, re-gauges, and then it can do it again.
The big short doesn't offer any resistance. That's why your amps go through the roof.
Yeah, it goes through the roof. Yeah, it just spikes like crazy.
Use a
like
coil with some kind of impedance that wouldn't be different.
Well, the proper way that Michael Kant said you have to use the cell is it'd be like inverse impulses. So it'd be 2 seconds on, 7 seconds off, 2 seconds on, 7 seconds off. So my ultimate goal is I'm going to make a 4 kilowatt generator system using these cells to regenerate my batteries. So I can have a 4 kilowatt system running all the time while the crystal power cells regenerate the batteries 24/7, 7 days a week. That's my goal.
Depending on how expensive they are, since a house doesn't move, you could literally line them up in your basement and start powering your house off of them.
Yeah, pretty much.
And that's what I'm talking about now. Why power your house? Why not power a shop where you got some sort of business that now you're not paying for your electricity, whereas Joe Blow down the street doing the same thing, he's still paying the electric company.
With it.
And you can basically use that to pump back into your other projects,
No, what you do is you hook it up to all your GPUs and start mining Bitcoin for free. How about that? How about that? There's
even better if it's actually turning that thermal energy into electricity. So that means it can siphon that heat out of that environment. Even if you got to throw it away on the roof, running a fan or something, you know.
You got it. No, you put the cells right beside the GPU. The GPU heats up my crystal cell and puts out more power. Thank you very much.
Right.
Well, don't get GPUs unless you're doing something that requires GPUs. Get ASICs because they're way more efficient. You'll generate money much faster.
With the the A6, yeah, okay.
Yeah.
Yeah, but I was just kind of making a point, the energy and the heat created by those, computer systems, that could fuel my power cells and increase the potential of the cell.
Sounds like these cells can also cool things down.
Well, I got to do some experiments with that. I got a thermal laser, so I can
let's find
do
out
some experiments with that.
So
curious.
I know the triboelectric system does that, but I don't know exactly how that's working. Like the triboelectric system requires a vacuum layer between the two with the gas particles moving back and forth, whereas a chemical system like that may just be using that jelly-like liquid to do its bouncing back and forth.
I'm using a solid-state polyethylene glycol as my dielectric in the middle, and it works fantastic. It actually has electric properties to it. So it's holding a charge.
Have you looked at the oil that comes in the old CRT video projectors? There's like an oil inside the right in front of the lens, in between the lens and the little screen because they're running so hot.
I'm using a sodium silicate, and that works really good. That's one compound, and the gel, the special electrolyte gel that I'm using.
I've got a bunch of it. I've been digging to see what people have done with it. So, because I can't find any information on how the stuff's made. I just know that it doesn't change any of its properties, even from getting like up to 300 degrees. Whereas most oils start breaking down at that point. So
it'd probably be almost kind of like the coolant that you use in the car. Probably similar because it has a very, very high boiling point, right? So it's probably an ethylene glycol type substance in it.
I don't know. I'll have to do some more digging.
Yeah, that's the.
I mean, it's
that's
not
the
easy to
first
come
I've ever
by.
heard of
So
that. Oh yeah, because
those
they
projectors are
don't make
disappearing
those.
now. Yeah, they don't make them
That's right.
anymore. So everything's DLP. So that's part of the replicator tech. I moved from the concept of using LCD arrays to shine the laser light through so that it can be turned into a pattern, to using DLP tech. So that way you can literally control an entire path of area instead of it just being a dot. Like right now, 3D printers with the fused filament, just one dot, and that dot has to make its way to every single area that plastic's got to be. Same thing with the laser whenever you're doing laser sintering even. But with that system, you just shrink that down then after you run it through the DLP, and now you can actually control a whole patterned array in one tiny little spot and hit the whole area at once. I've got a concept too for the filament where it uses like a slit, and instead of the whole slit being open for the plastic to flow through, you have square pins that drop down in there, and then you can retract whichever pins you want to make the line any pattern you want while the head rotates around to basically if it's possible to get enough heat for that whole thing and whatnot for like 1,000 pin width array, we'll be looking at being able to print something that takes 3 hours to print. It'll print in 30 minutes.
Wow.
I'm ready to go.
Anyways,
I mean, not 30 minutes, sorry, 30 seconds,
Yeah,
So
that's amazing. Thanks for coming on. We're going to end the show. We've been on 2 hours and 35 minutes. I'm pretty tired. I've been up since early this morning. So Nathan, Ben, Mike,
send me that guy's channel URL, the one that was on earlier.
Gerald's. Okay, hold on one sec. Just bear with me for a minute, and we'll call it a night. My internet's starting to crap out on me here.
You only got 38 comments on YouTube? Is that what that's
Holy.
saying up there in the corner?
Well, the
I'm
live
gonna
chat.
put mine in
the
chat
live
as
chat-
well.
See, I wonder how many people are being censored, so whatever they're typing isn't coming through either.
Yeah, my internet's been kind of funky tonight.
You know,
so
I used to
think
get
we
censored
touched on.
too. When you use words like, you know, shit and stuff like that, the algorithm starts watching you.
Yeah.
What you type.
Yeah.
There's a lot more that it seems to watch for too that seems way more innocuous. So I've been noticing that.
Hold on here, I'm having troubles with my.
I wonder how that's the Google breakup is going to affect all that, because they're getting ready to be monopoly busted. So
Yeah, the Google thing with the privacy. Okay. Trying to get Gerald's email.
I'd say that privacy thing probably isn't going to matter now. You saw that thing where over, what is it, like 2.4 billion people's social security numbers and whatnot had been leaked somehow.
Okay, in the private chat, I just posted Gerald's email, so you can get a hold of Gerald that way. It's in the private chat. You see the tab where it says private chat. All right, guys, thanks. This was a great show, awesome show. Please come on again. You're a wealth of knowledge. Yeah.
I'm going to be doing
show.
some. I'll have to do them on Rumble, but I'm going to be doing some like presentation things as soon as I get everything sorted. Not only whiteboard everything so people can understand what I'm actually doing, but also the physical.
So after
testing, so they can see that it works. Because I'm really wanting people to take advantage of like that thermal diode tech.
What's your Rumble account? Do you have a name on it?
Morph Trust, same as the one that I put in there. What is it? YouTube.com/@MorphTrust. If you use that same name on Rumble, that's my primary channel, and everything else is umbrella underneath that.
You can also put it in the comments after the show, and then people can go back to the comments.
Maybe that won't get censored. Yeah. Only way to find out is to refresh the page and look and see if it's there. I got to where I started opening. Anytime I was watching a live chat, a live stream on YouTube, I'd open 2 instances and put one on each of my screens on my computer, so I'd know if something's getting through. Because if it's not getting through, you know, what's the point in trying to communicate with somebody whenever they've been deafened by someone in between?
Yeah,
that's a pretty common exploit. You can actually do that to increase your views a little bit. Put a view on each window. Tell your viewers to do the same, and then just increase it.
I was doing something kind of like that on Twitch, but not intentionally. So
yeah.
Thanks, guys.
Thanks everybody.
Thanks,
guys. Thanks, Nathan. Mike.
Yeah.
Mike.
Take care. Take care.
Nice meeting you, Thomas.
Night.
Take care. Bye. Bye.
Alright guys, I'm gonna wrap up the stream here. I really appreciate everybody for stopping by and hanging out with us tonight. We've been streaming for like almost 6 hours. Wow. So again, we started the stream with debunking the Mythbusters Bedini Motor episode, and that was pretty tragic. It was a shame to see, and it was a shame to have to do, but we did it. And if you'd like to see that and you missed it, you can always rewind and watch that. That was fun. This was really cool. Appreciate everybody. Catch you next time. Peace.
Remember, if you like my content, please consider subscribing and hitting the like button on my videos. Comments and any form of engagement dramatically help us break through the YouTube algorithm. I also have a website with research on the Thunderstorm engine, plasmoid technology, and do-it-yourself guides from Malcolm Bendel's Retrofit, courtesy of Jordan from Alchemical Science and the Martin Fleischmann Memorial Project. Check out my store for exclusive merchandise along with our forum, where you can post questions, share videos, and join in the community to help destigmatize all forms of forbidden knowledge. Don't forget to check out Jordan's channel Alchemical Science and Bob Greenier from the Martin Fleischmann Memorial Project YouTube channel. They're on the cutting edge of cold fusion technology. More updates on that coming soon. Stay tuned.